Dear ladies and gentlemen, welcome everyone to the second edition of Baltic Fire Forum. I greet you from Vilnius, the capital of Lithuania, Litexpo Trading Conference Center, our media center, our online temporary home for 2 days. I'm really glad to see so much already connected viewers, and I'm really amazed by the geography that expanded, from the first time when we'd done it 2 years ago. It was meant only for Baltic region, Baltic Sea region. Now we have a geographic from Spain to China, from Finland to Ukraine. So thank you very much. Thank you for this achievement. We couldn't do this without you. This time, no live trainings. We have no containers with fire and flames. We do not do any hot smoke tests. We do not shake our hands when we meet. But nevertheless, the quality of this event, even though we do it online, the quality is rising and rising. I'm really glad to see so much professors from universities, specialists from accredited laboratories who are joining with their presentations. And it's really amazing how fire engineering is advancing. It's some day ago it was quite a challenge. Now it's advancing every single day, and I'm very thankful that you are joining this event together with us. Every forum has kind of a mission. Our mission was chosen with very clear view. It's zero casualties caused by fire in Lithuania, zero casualties caused by fire in Latvia and Estonia. Is it possible? Yes, it is. Okay, not tomorrow or maybe not in 1 year, but you will ask, how can we achieve that? Having all the most modern technologies in the world. Smoke detection is so much advanced. Smoke exhaust, firefighting systems, all they are installed in the building, and still we have some casualties. Our firefighters are getting more and more effective. Why? Well, maybe that's a mindset. Mindset is always the thing that could be changed. Of course, it's not very much easy, but our mission and our goal is to reach it by 2025, when we once again meet in the Baltic Fire Forum. So changing the mindset in our engineering way, I think if we start by doing and feeling this social responsibility, which is not just the words. In our engineering world, the designing with responsibility means saving someone's lives. And I hope that Baltic Fire Forum will be this platform when firefighters and fire engineers can share this knowledge, and we can achieve this zero casualties goal. Thank you very much for joining me today, and I hope you will like it, this 2 days journey in fire safety engineering. Welcome and enjoy.
Hello, everybody. My name is Wojciech Węgrzyński. I'm with the Building Research Institute ITB in Poland. And today I'm invited to talk to you about natural smoke control in wind conditions. So let's get on to it. First, let me briefly introduce myself. I'm an associate professor at ITB, and I did my PhD on the role the architecture plays in the smoke control. My further research was on the smoke removal under environmental conditions. So that's why I'm here talking to you about wind and smoke. And since 2010, I'm an active designer of smoke control systems, consultant, and I do a lot of CFD analysis that are used in the design of such systems. I'm also heavily involved in Polish SFP chapter, and I really look forward to having you guys as a chapter as well in Europe. Let's get on to the main part. So why should we talk about wind and fire? Why should we consider wind as a factor? Well, it is quite obvious that fires under wind conditions will be different than fires that are not in wind conditions. And as we know, most phenomena connected to fire will change, usually to the worse with the fire, with the wind. With wind, the fire spreads quicker, the smoke moves further, and what's absolutely the worst, it may cause unexpected changes in internal flows that can surprise firefighters or occupants. If we take a look at this from thermodynamics perspective, the wind can be considered as an exogenous external driving force, while the fire inside and the buoyancy created by the fire is an internal force. And as our natural event connects these two volumes together, the performance of the venting is always an outcome of these two forces battling with each other. So we cannot speak about the performance of natural ventilation without including the external forces. We also know that wind can cause some major disturbances in smoke control and heavily increase the severity of fires. In a research study by Fire Protection Research Foundation of NFPA, it was found that out of 565 fires that included fatalities, in 342 incidents, you cannot exclude that the wind had an effect on the fires. In 30 of these, the wind had confirmed impact, and in 55, the impact was determined as probable. So, at least in 15% of all fires with fatalities in them, the wind was a considerable aspect that led to this terrible outcome. So, what happens when when your building is subject to a wind? Well, first of all, outside of the building, we start to have some forces that happen because the wind flows around our buildings. The vortices form above, behind our buildings. This air movement around the roof will cause local pressure effects. It can either push the air down to the roof, it can suck the air above the roof, depending on where you are against the edges of the building. So a complex array of pressure and flow effects will occur at the roof of your building, exactly where your vents are. Inside it will be also interesting because the pressure will act on the facades of the building, creating indoor flows. And these flows can do complex things. They can disturb buoyancy of the smoke, and by this action, they can cool the smoke and prevent the indigenous forces you would have driving the smoke control system. They can also impinge the flame plume, the smoke plume against the walls, and cause very complex fire dynamics. Or they can just supply more oxygen to your fire, which also can lead to a worse outcome if your fire was already ventilation controlled. Finally, if we start to consider what happens beyond our building, if we start to think about what is the outcome of a building fire to its surroundings, the wind is more important than ever because the wind will be the force driving the large thermal plume outside of your building. It will determine how far and how severe the smoke plume will be. So no matter how you look at it, from inside, outside, from the original point of view, wind is critical for smoke exhaust. So we know that it's not a new lesson that wind is critical. So how can we deal with that? Well, the way how it's been dealt with for more than 30 years is to be included in the design of natural vents. So it's obvious that the wind will limit the ability of the natural ventilator to remove the smoke from the building. Thus, this effect has been calculated into the design of such ventilation devices. We do that by placing the vents in a wind tunnel, supplying air into the vent from underneath the wind tunnel and exposing the natural vent to a wind velocity of 10 meters per second. And by rotating the ventilator, we can find the most adverse angles of wind attack for which the performance of the natural vent is lowest. And through this concept, determine what is the so-called aerodynamic free area or the discharge coefficient of this ventilator. And this can be further used in the design. In fact, this parameter, the discharge coefficient, is well placed within all renowned methodologies for calculating the total amount of ventilators you need in your building. So if you are designing a building and you want to calculate what is the exact number of ventilators you need to remove the smoke from a particular fire, you are usually in the end referring to the aerodynamic free area in one way or another. And to do that, you need the discharge coefficient, which is exactly the thing that we measure in the wind tunnel. The discharge coefficient is just an aerodynamic resistance of the opening of the vent, and its physical meaning is the lower performance of the vent, the higher the pressure above it is. So with increasing pressure above your vent, the mass flow through that vent will be lower, and by comparing these two values, we can determine what's the average drop in the efficiency compared to a perfect opening. That's how we determine the discharge coefficient. And to do that, we obviously use wind tunnels, and I'm very, very proud to say that we have just opened a new wind tunnel at ITB in Poland, and we are on our way to get it accredited with our national body, which should happen somewhere like in 2 weeks. Um, it's gonna be used to test all kinds of natural ventilators, and yeah, it's a great facility. It's actually quite huge, if you may. It's a great place, and I hope it will be home to many great tests, and I hope it will be home to great science. And in fact, this is the state of art in most of the world, because very rarely someone goes beyond this. I mean, the wind is incorporated in your natural ventilator design, so why would you bother with that anymore? You already calculated that factor. But in fact, that's just a half of the story. In ITB, we have taken these considerations much further with the use of numerical modeling and some advanced simulations. Because you see, it's very difficult to close all the ventilation effects happening with the wind into a single value or a discharge coefficient. The wind in a terrain, in urban terrain especially, is causing some extremely complex effects. On the left side, you can see three simulations of 10 meters per second wind in an urban environment, and these cases differ only by 90 degrees, so it's a small difference in the angle of the wind. But you can see the outcomes of these three simulations related to the flows around the building and the pressures, which you see in the middle column, is completely different, from overpressure next to the building to severe underpressure on the roof, from no flow directly impinging on the inlets to the building to 10 meters per second flow directly into the doors of the warehouse. And this results in a complex three-dimensional flows inside the warehouse that we are trying to protect. And as you can see, these three images on the right are completely different. With three different wind angles, with three different situations, you get three completely different outcomes of your smoke venting action. It's not only the velocities that change; it's also the shape of the flows, the direction of the flow inside of the building. It's many factors that would be considerable if this was a real fire in the building under these conditions. Um, of course, it's difficult to analyze such complex behavior from plots of vectors. So we try to merge this research down into hopefully single value that can be used to describe the efficiency of the system. And in this case, we have done that by combining the mass flow rate through all of the ventilators in the building. This means we measure the mass of air and smoke that's being removed from the building in question. And as you can see, the dashed line represents situation where there was no wind present. In many of the cases, the mass flow is lower than in no wind conditions, but in some cases, the mass flow is much higher than in no wind conditions, and that's quite surprising and interesting because you can see that wind does not necessarily always mean the outcome will be worse. There are some angles of wind that combined with your building placement architecture and combined with the local effects that may happen in wind conditions may actually promote a better exhaust rate than you would have without wind. But well, generally we consider it being worse. um, this single number is very interesting to analyze the overall performance of the system. However, it does not give a full answer on how does the wind affect your smoke control. For this, you should really investigate your particular ventilators, because that's another kind of lie we live in, that the vents will have the same performance. They will not. Their performance will be determined by indigenous and exogenous forces on each vent separately. So it's not possible they all behave in the same way. It will always be an outcome of the battle between the buoyancy and the wind at each ventilator. The vents will have considerably different performance. They will considerably different amount of mass of smoke will be removed through them, and they will have completely different flow velocities through them. And as such, in my opinion, you always have to look at particular events if you want to design a truly efficient system. And it's also important that because the performance of these fans is so vastly different between them, um, and because your building aerodynamics will be vastly different depending on the wind direction and velocity. You never know which vent will be in overpressure and which vent will be in under pressure, and which will be the efficient one, which will be the not efficient one. So it's very important that we really use all of them to really have the efficient action of the whole system as one organism. Otherwise, we will you may end up with activating a single vent that's in heavy overpressure, and no matter that it's above the fire, it will not really remove smoke efficiently because the wind will push the smoke back. So if you really want to prevent that and you really want an efficient system, it's very important to consider it as a whole body, as a whole system that must act together. And with this, you can really benefit from mitigating the wind effects by having these fans in different positions. And obviously, placement of the vents is not the single thing. A lot will depend as well with the type of your ventilators. We If you just use the CV values, the discharge coefficient values, and you look at what the manufacturers are offering, you might at times notice that you have this wall window type natural ventilators, you have roof type ventilators, and they may have quite similar values of the discharge coefficient on them. However, the trap is that the ventilators that are meant to be used on the walls of your building are not necessarily tested in wind conditions. So while your roof ventilators are always subject to wind, the wall ones are not necessarily. And here you have an example of simulations. Actually presented this in Vilnius some years ago. Um, so you can see the results of the venting action in a building fit with roof ventilators and facade ventilators. and the outcomes are considerably different. And in scenario A1, we had no wind and just perfect conditions using the roof. And in the bottom one, the C4, we had wind pushing against the natural ventilators on the facade that was exposed to the wind, and this led actually to reversed flow. The air was coming into the building through the natural vents and being removed from the building through the doors. So a completely reversed action, leading to very, very dangerous situation for the building occupants. So another lesson comes from this, that if you are using ventilators on your facades, the considerations related to the wind effects are way more important than if you just consider the wind actions on your roof. And from my experience, it is close to not possible to design a natural ventilation system with openings just on one facade. We only have done that once, and it was a very difficult project, and we had to use mechanical support. This is because if at some point you end up having this facade exposed to wind, there is absolutely no way the internal forces can be stronger than the wind action. So as we go into the roof aerodynamics, and as we go into the performance of natural ventilators on buildings, considering the system of a building ventilator and a fire together, we also realized that it actually may be possible to improve the performance of natural ventilators in wind conditions by changing the roof aerodynamics on purpose. And that's something we've been developing for the last 3 years. We've called that aerodynamic elements for natural smoke ventilators. And this idea is that in a contemporary design of natural ventilators, the aerodynamic elements are fit directly on the ventilator to improve its exhaust rate. And we are not constrained, as a scientists, we are not constrained by the standardization and other requirements that would not necessarily approve this. So we figured out what would happen if we just took these aerodynamic elements, just make them slightly bigger and place them in a distance of the vent. So for the worst wind angles, the vent will always be in an under pressure. And if the vent is in under pressure, then the wind is helping your exhaust action. So we actually did the preliminary experiments in CFD, and it kind of worked. So we've turned into a more complex study where we did a parametric analysis in a numerical wind tunnel, having a vent in the tunnel with different types of aerodynamic elements in front of it, to see how this system will behave at different wind velocities. And as expected, the differences are quite substantial, because as you can see on this illustration, on an unshielded element, you have a large pressure increase in front of the ventilator. That essentially is the blockade of the incoming air that traps your air in the ventilator and works against your smoke. And on the right side, you have the ventilator shielded by an element where the ventilator is essentially in the shadow, or in the aerodynamic shadow of that element. Just imagine having a bicycle and driving behind the truck. It's gonna be always easier than just driving alone. Unless the truck stops, then it's not gonna be good. But however, here we've put the vent in the shadow, and we've received quite interesting results. So if we consider just this purposely fit aerodynamic ventilators elements, no matter which one we've put in front of the vent, it always ended up better than than the smoke flow, than the CV value without one. And what's astounding, we've reached CV values of more than one, which like technically makes no sense if you're considering just the vent alone, but as a system, it kind of does. So these elements can really improve the efficiency of your vent in case of wind acting from a particular direction from which this vent is shielded. And if you do the roof aerodynamics study, you can find this angle. So it's quite easy. But yeah, your roof is full of elements, so why not use different things? And we've also done that. We've tested how different objects on the roof, like large ventilating units or other vents, will behave. And the results were interesting because some of them improve, some of them make the CV value worse. So it's varying, but however, we found that if you really purposely fit an aerodynamic inlet element in front of your vent, you can really improve the smoke efficiency. And now to give you some summary, um, I always like to do that in identifying the gaps of knowledge. Like, I've told you what we know. Now let's discuss what we don't know. So, in the design of natural ventilators, the paradigm now is that we consider an individual vent. And in my opinion, it should be that we consider the system. It's not really feasible to consider just the aerodynamic parameters of a single vent, while every vent on your roof will have a different parameter. The second thing we don't really know is we're not perfectly aware which parameters will be key for the performance. I mean, it's obvious that the wind and the temperature are important, but we have no idea what other parameters will be important. Will the ambient air temperature be important? Will the humidity be important? We don't really know that, and that's something that we need to investigate to have a complete image of this. Furthermore, the CV value as an ultimate measure of the performance of a ventilator is definitely needs to be improved. And for the systems in complete overview, well, um, the vents will interact with wind, and you must consider that. And we need more research on this. We're doing this research, but hopefully more scientists will join us. Furthermore, we don't know what happens in ventilated and double skin facades of our high-rise buildings, which also are exposed to winds, often more severe winds than the normal buildings, and really need to find out how this will behave in fire. And lastly, we really need coupled wind and fire risk models, and that's something that is driving our research at this moment. Well, thank you very much, and I'm really happy to participate in the forum in this way. Hopefully, next year I will be able to join it in wherever the conference takes place. And I hope you enjoyed that. If you have any questions, the easiest way to reach me is through Twitter, probably, but you can also drop me an email and I will answer. Thank you very much.
Thank you very much, Wojciech. I'm really glad that you took my invitation for the second edition of Baltic Fire Forum and agreed to give us this speech, very interesting one. I'm sorry, I just went back in my mind to the university times because this topic is quite tough. You know, while doing fire safety design, I don't remember anybody to take attention to the wind direction. But well, it's interesting. How about you, Gustavus?
Yes, it's very interesting. You know, the smoke is the most, I think, dangerous substance in fire. So it's and what in reality? Maybe Martinas, you have met some situations.
Reality. Well, and yes and no. The fire is not my firefighter's experience was very short one in my life. More,
but also very good, I think.
Fire prevention is much more.
Yeah.
But to tell you the truth, we've seen this effect during the hot smoke test.
Okay.
So when we've done some tests in underground garages with open corners or some open spaces, you can see that effect. Especially we had one object here in Vilnius, and we saw when the jet fans were pushing the smoke in the upwind direction. So it was a very slow, rather slow than normal flow of the smoke, and finally it stopped. It was like 30 seconds, and then slowly but went back. In the end, all the all the garage was filled with smoke. So this effect was like a big surprise for us, and nobody could understand why this effect took place. But now when I saw Wojciech's presentations, so I say your question is very actual here. But yeah.
Okay, and you saw this effect during the smoke test.
Yeah.
And do you recommend this test for others, for all the systems, only for some special systems, only
Yeah,
some spaces?
we can basically make it also for gravitational, as we saw smoke
Okay.
exhaust systems. Maybe mechanical ones, the ones that you can see more by your eyesight, but it's also good logic. Do you understand what is happening and why?
Yeah,
What is really the reason?
I agree with that.
But I don't know how about you, but we've seen also the differences even in pressure when there is no wind, but you can do the tests, the smoke exhaust, during winter and during summer.
My practice is very small in the
In
smoke
this area.
testing. Yeah, so
Let's go further then, where your practice area is much larger. And now we shall talk about cabling. Fire resistance cables are very important role for every functioning, fire safety equipment, the pumps, the ventilators, and so on and so on, emergency lightings. And yeah, just to keep it, we have to have fire resistant cables, but it's not the end. Karolis Kuzelis will tell us a bit more in details of how important it is to fix and mount and see the installation of fire resistance cables. This is very important situation and very important issue, which will be presented by Obbo Betterman company. So Karolis, we are waiting for you to present your next slides.
Hello everyone, my name is Karolis Kuzelis. I'm product manager for fire protection systems at company Obbo Betterman, and today I'm going to introduce you our topic, installation of the cables with integrated function maintenance. So sorry. Okay, so first of all, let's talk about what it is, function maintenance. So if there is a fire, escape and rescue routes must remain usable, and important technical equipment such as emergency lighting, fire alarm systems, and smoke extraction systems must continue to function. In addition, certain technical systems must support the fire brigades in fighting fires for a sufficiently long time. To guarantee the power supply for these systems, meaning that the electrical functionality is maintained, the appropriate installations must be equipped with special routing systems. Function maintenance is applied to buildings and plants with increased safety risk, such as hospitals, hotels and restaurants, high-rise buildings, meeting sites, office buildings, enclosed car parks, underground railways, chemical industry plants, or power stations. These buildings are frequently visited by a large number of people, creating an increased safety risk for people. However, with certain systems, also property and environment must be protected. There are different requirements for function maintenance. First, 30 minutes play an important role when escaping the affected building. During this time, the maintenance of electrical supply must be guaranteed for the following equipment, such as safety lighting systems, fire alarms, passenger lifts, systems for alarms and giving instructions to visitors and staff, and natural smoke extraction systems. The other requirement is 90 minutes. It is necessary to maintain function for a period for 90 minutes, and the following equipment must maintain functional. It is water pressure boosting systems for supplying extinguishing water, water pressure boostings for sprinkler systems, mechanical smoke extraction systems, and fire brigades lifts and bed elevators in, for example, hospitals. So in other words, 30 minutes are for safe evacuation, and 90 minutes are for fighting fire and difficult evacuation. All these systems require electrical power, which is supplied through cables. To ensure that cables do not burn and will be functional in case of fire, there are some simple solutions. They can be laid in the ground or beneath the concrete, but in the most of the cases, this installation is simply just impossible. So we have two more options. They can be laid in the cable ducts, but this installation is not very practical and it's quite expensive. And other solutions, we can use a cable system with integrated function maintenance. This system is most frequently used in most of the cases because it's most economical and most practical, but it's very important that it should be installed correctly. All these systems has to be tested and certified, and main standard for it is DIN 4102 part 12. As you can see, there are classifications for the DIN standard. These classifications are for ensuring function maintenance for 30 minutes, and it is marked as E30. For maintaining functionality for 60 minutes, it is E60, and for 90 minutes, it is E90. Let's look how tests are made according to the DIN. So as you can see, for these cable systems with integrated function maintenance, routing is appropriate for practical use. Test length is 3 meters to get most real results, and heat temperature is according to the standard temperature curve, which is widely used in whole Europe for fire tests. And now it's a very important part. It is clearly defined in DIN standard that cables and wires with integrated function maintenance plus laying system for it, only both of them together, which is very important, only both of them together creates an electric cable system required to maintain circuit integrity. So in other words, cables with integrated function maintenance has absolutely no purpose if they are not fixed correctly. They would fall off and break, leading to system failure. So it is very important that laying system would also be tested and certified to perform good enough in case of fire. There are some different standards in Europe for function maintenance, but none of these standards are comparable to DIN, because all these standards covers only cable insulation testing. and these test arrangements has no relation to real installations. Here you can see an example for one of these tests. So fire is applied only to cable, and it's checking only cable insulation performance in fire while it is stationary. But let's look a little more deeply at these fire-resistant cables. So cables with integrated functional maintenance are made with Ceram insulation layer. In the event of fire, the special plastic forms a ceramized insulation layer, which ensures that current still flow. That's okay. The copper conductors remain separate and do not short out. But here, look at the cables after fire tests. This insulation layer, Ceram insulation layer, is very fragile, and in any little deformation, they break, and this could lead to copper conductor cutting or system shorting out. So it is very important that whole cable laying system would also be tested. For this application, according to the DIN standard, we are using a testing furnace where temperature is achieved by standard temperature curve, as you can see, which is widely used in whole Europe and other international testings where it's very close to a real fire temperature rising. Here you can see test arrangement, how it looks like inside the testing furnace. So it is, test length is in 3 meters, and we have whole system, the hanging brackets, ceiling brackets, cable layers, cable trays laid in the cable trays, also applied chains for additional load to make it real practical installation. Also, there are forming cable bends because sometimes they appear in real installation, and it also has to be checked. Also, cables are connected, and it's always measuring the current flow and checking that system wouldn't short out and will be functional in the fire. And now let's look inside what's happening during the tests. In this testing furnace, there is a small window where we can always look and check how system is performing. So at the first minute, when it is just applied burner and fire just started, temperature is at the normal room temperature at 20 degrees. After 20 minutes, we have almost 800, and system is still looking the same. Everything is fine. After 30 minutes, also nothing special happens. Everything is still fine. 40 minutes, a little deformation is already visible. After 60 minutes, look, the whole steel trays, brackets, everything is started glowing, and deformation is clearly visible, but everything is still in place. And after 90 minutes, deformation is appears even more, but everything is still hanging there, and system cables are checked, that current is still flowing, cables are working, everything is fine. So this system passed the test and it can be used. Here you can see an example of a little lighter systems where spacing between brackets and the whole cable trays are from thinner metal sheets. So it doesn't look that good than previous our example, but this system also passed the tests, but it has to be checked. And look a little closer to what's happening to the cable insulation. As we saw in previous examples, and here in the tests, we have the same, that this insulation layer is very, very fragile, and there shouldn't appear any big deformations, and it has to be tests how much deformation we can apply that cable will still be working. So according to the DIN standard, cables can be fixed in 3 ways. So it could be single cable installation beneath the ceiling, or cables could be laid on cable trays, or cables can be laid on cable ladders. So let's check each system a little bit closer. So first system is cable ladder system. It is tested for standard hanging system from the ceilings or wall mounting. And it is tested for E30 and E90 minutes. Here you can see the system properties. So it is supported, suspended system. Brackets should be screwed or welded. Also, additional threaded rod should be installed, which is not normally used in the normal conditions. Cable ladder width maximum could be just 400 millimeters. Cable ladder strut height is 60 millimeters, which is normal, and metal thickness is 1.5 millimeters. Well, here it is pretty much same requirements as in normal conditions, but look at the maximum suspended spacing. For cable installation with for cables with integrated functional maintenance, maximum support spacing for these cable ladders can be just 1.2 meters. And cable load is also crazy low. It is permitted just for 20 kilograms per meter. And let's compare it with the normal conditions. Same cable ladders in the normal conditions can be installed up to 4 meters spacing at the spacing between brackets where cable ladders are installed. And cable load can be at 330 kilograms per meter. This is at 1.5 meter spacing because this is the lowest spacing it is tested, because in the real practice for normal condition nobody is installing in less than for example 2 or 3 meters these cable ladders. But for fire resistant cables it has to be installed at maximum at 1.2 meters. So comparing maximum permitted load, it is 15 times difference. Okay, let's check other systems. So next system is cable tray system. So it is also tested for E30 and E90. And let's jump to the properties of the system. So same, it can be installed as suspended from the ceiling. Also for the brackets, we have to use additional threaded rod. Maximum cable tray width is just 300 millimeters. Normally we achieve till 600. Metal sheet thickness is 1.5 millimeters, which is also quite big because in normal conditions, standard cable trays are installed in twice thicker. Suspended supports are maximum spacing for 1.2 meter, and maximum cable load is even less. It's only 10 kilograms per meter. So comparing this to normal condition, we have maximum support spacing in 3 meters for the same cable tray, and cable load is permitted for 265. And look, for fire-resistant cable installation, it's only 10 kilogram per meter. So look how big different it is for these systems. So it is very, very important that cables with integrated functional maintenance will not be installed together with other installations where we have big support distance and big cable load, because they will collapse in case of fire and will not work. Let's get back a little to example of the tests. So please note that this cable tray, what you see in this test, is installed with more than 25 times less cable load than it is permitted at normal condition. And still there is such a big visible bend and deformation for the cables. So you can just imagine how it would look like with greater support distance, what we achieve in normal conditions. Here is spacing just 1.2 meter, but in normal conditions we have 2 or even 3 meter distance, and cable loads can be 20 times bigger than we have in this test. So it is very important that this system also would be installed correctly and according to the standard. Also, other installation, if we have only few cables, it could be single cable installation where we use single cable clips. So it is just one very important thing, that also clips have to be certified that they will perform good enough in case of fire, and they have to be installed in every 300 millimeters. So it's very close, clip after clip, because not to achieve just very big cable bend. For vertical cable installation, there is 2 options. It can be also single clip installation, also same fixing, maximum 300 millimeters, or it can be installed on the vertical cable ladders. There is pretty much same as at horizontal properties, maximum 20 kilogram, maximum cable ladder width is also 400 millimeters, so nothing very special compared to the horizontal installation. There is only one big thing, that this vertical installation can be not maximum vertical installation can be just 3.5 meter. If we achieve more than 3.5 meter, we have to make horizontal bend or if we penetrate ceiling, there should be installed an insulation system. Or if nothing is possible for this, we can use a strain relief unit, which has to be installed in every 3.5 meters. So as you can see in this picture, there are all examples how vertical installation has to be done if it's more than 3.5 meters. So there is horizontal bends or strain relief units, or if we penetrate ceilings, there should be installed insulation layers. Also, some lighter systems can be used, what is not written in the standard, but all these systems has to be tested and certified. So here you can see Obo-Bettemann RKS Magic cable tray, which is also tested for fire, for functional maintenance. This cable tray is twice thinner than standard. This is just 0.75 millimeter metal sheet, and it has a quick connection when cable tray just connect one to each other without any screws. So it's very practical, but we should always keep in mind that it has to be installed that way it is certified. So we have to follow what is written in this certificate for these systems, how they are tested, what cables were tested with it, and what supporting systems for these trays were used. Also, Obo-Bettemann has tested a meshed cable tray, which also has a magic connection where mesh cable tray connects to each other without any special connectors. They only connect one to each other. But also, it is very, very important that we will follow what is written in this certificate and do not exceed bigger cable load or bigger support distance. So when we are testing these systems, lighter systems, we are looking for a best, most practical, but still performing good enough system that will ensure that the system will be working in case of fire. So look again what's happening for the cables. So it is just finding this best, most economical way. But if this support distance would be a little bigger, I think these cables wouldn't work. Also, we have tested some grip collectors for bundle of cables for a wall or ceiling installation. These are pressure clips for bundles of cable. This installation is very good if we don't have space for other installation. And also, it is very important that cables with function maintenance should be, sometimes we have to connect them or distribute for the branch of cables. So we have to use a junction box, but it's also very, very important how and what junction box we are using. So it also has to be tested and certified for this purpose. So for this, OBO can offer our called firebox. As you can see, they have a special clamps. They are fire resistant, and they are connected to the whole supporting system with the metal sheets. So they ensure that cables will, in case of fire, they will still be in place. So let's look how it is tested. So as you can see, this plastic cover just melts and nothing leaves from it. But these ceramic, fire-resistant ceramic lamps and its supporting system ensures that cables will be connected and they will be in place, and they won't be cutted. So that's it of cable installation with the 4 cables with integrated function maintenance. Thank you everyone for your attention. Now you know that it's very important that fire-resistant cables should be installed correctly, and we have to ensure that these systems we discussed at Forum, which need electric power, will be maintained functional in case of fire. So thank you and bye.
So thank you very much, Karolis, for this presentation. I even now find it that cabling methods are even more important than fire resistance of cables. So I'm just joking, of course, but they're very, very interesting thing. Kęstutis, how did you like the presentation?
I think that presentation is very important. It's when we are talking about the electricity for the fire safety equipment. For example, it's fire smoke exhaust systems, it's firefighting systems, extinguishing systems, emergency lighting. So it's all related in one place, and it is depending on this electricity support system. So, and when we're talking about the cabling, so it's if you have a good cable but not good supported, so we are not sure that electricity will be during the fire. So I think that this topic is quite important for all fire safety in the building. So
yeah. I think maybe not everyone, but I myself thought that the cables are quite flexible ones. But yeah, but during the fire and during fire tests, we see that they are very crushing even, and all these installation methods are so important. For me, it's just one question about DIN and our local norms. I do understand that Baltic fire codes, maybe they are quite similar, but no one talks about this kind of best practice or methodology. How do you find this DIN and local codes? You know,
yeah, we have how to say, and good and bad situation at the same time, because the DIN is not obligatory document for the Lithuania market, so it's we can use, and we haven't any obligation to use it. So if we can use, we can use. We can put in the design, we can put in and install according to the DIN.
Okay.
But it's not forbidden. And but we are not sure that all designers or fire safety designers are using and know that and implementing correctly. So it's, I think, very difficult to implement for the 100% for all the buildings. So it's
But the advantage of this DIN, I do understand that it gives you how to do it. The local norms are not saying how to do it.
Yeah,
So if we do
correct.
something better than our local norms are
Yes,
saying,
correct.
then why not?
Yeah.
So I would encourage every electrician engineer also to think about it, because it's also about social things, about responsibility, at least about the engineering way of thinking and responsibility.
Yes, of course. And also we inviting all the people to communicate about that, to know a little bit more about that, and maybe issue some documents, local documents, where is mentioned the main parts.
Okay.
And then at the same time also we have a lot not solved points in fire safety. So, and this one is of the, how to say, few questions in the row.
So once again, I'm just very glad that the second edition of Baltic Fire Forum becomes a platform of good practice, of the finer future for everybody of us, and we can show that all the things can be done. It's just a matter of time, probably, and a good will. So, Karoli, once again, thank you very much for your presentation. It was a good start. Enter to our next topic, which is about smoke exhaust systems. And let me introduce you Linas Kriščiūnas from a company Promat, who will talk about smoke ducts. Few years, maybe even 3 years ago, we had a very different and very problematic situation because of lack of certified products. So Linas will present now about the certification, tests, and the systems which are certified and ready to use. So Linas, the stage is yours. We are waiting for your presentation.
Good morning to everyone. Maybe it's good afternoon for you. Dzień dobry, dobry dzień, labdien. I'm really glad to have a possibility to participate in such forum. And my topic is smoke extraction ducts according to European Harmonized Standard 12101 Part 7 in 3 and 4-sided configuration. When I say harmonized standard, it means that it is accepted in all EU countries. And I assume that this topic should be really interesting for HVAC professionals, fire experts, technical supervisors. And my presentation will be a mix of commercial and for the technical people, so it could be suited for more or less all of you. But before we will move on, I would like to tell a couple words about myself and the company I represent. So my name is Linas Kriščiūnas. In Netex, I'm for 12 years. For the last 6-7 years, I was responsible for Promat development in Baltic countries. And when we talk about Promat, we talk about passive fire protection. And I think most of you will agree with me that fire protection, it's quite a difficult topic. It's related with dozens of certificates, test reports, classification reports, requirements which differ country by country. And from my experience, for example, in Lithuania, we have much more stricter requirements, while in Estonia it is much more easier, and so on. So the company I represent, it's the ETEX group. It's a huge industrial group manufacturing high quality materials. And one of the businesses Promat ETEX is focusing is passive fire protection in buildings. So when we talk about passive fire protection in buildings, we have various solutions like fire stopping, steel protection, concrete protection, fire-rated ducts, or smoke extraction ducts, about which I will be talking today. And you know, at the end of the day, products are coming to the job site, and the main focus in Baltics is our calcium silicate boards. I have it here in my hands. So these boards have certificates, are tested for certain applications. As I mentioned, might be used for the steel protection, ducting, shafts, and so on. So let's move to the presentation. The key points of presentation is I did it in 3 blocks. Okay, the main 3 blocks is smoke management. The second is requirements and procedures in Baltics for smoke extraction ducting according to 12.101 Part 7. And then I will share some experience on our certified solutions for the ducting in 3 and 4-sided configuration. So let's move on to the smoke management. So one of the most hazardous situations that can be faced in the building is smoke. And while fires themselves are often damaging, but it is the smoke that can cause the most of the injuries. And in order to protect building occupants, well, people, as well as what is inside, furnishing, equipment that might be damaged by smoke, a smoke control system is needed. And a smoke control system controls the flow of smoke in building in the event of fire. So it keeps the smoke from spreading throughout the building and gives the building occupants, people, a clear evacuation route, as well as preventing further damage to the building, what it is inside. Yes, and here we talk about ductworks, and when we talk about ductworks, we should understand that it's important element of fire safety system in buildings. And here I want to underline that depending on its role, we can distinguish 2 types, which is smoke extraction or ventilation ductworks. In some cases, it can be named also as fire-rated ducts. So we have 2, smoke extraction and fire-rated ductworks. Why I'm mentioning it? Because from the experience which I have while visiting the job sites, dealing with HVAC designers, installers, construction companies, I noticed that they, in some cases, they are mixing and thinking that fire-rated duct is the same as smoke extraction duct, which is totally not right. The purpose of these ducts are different. The test standard is different. The certificate is different. The system, the products might be different as well. So I want to explain in one slide the differences of fire-rated ducts and smoke extraction ducts. So when we talk about fire-rated ducts, they used to guarantee the fire compartmentation. More precisely, fire-rated ventilation duct can avoid fire and heat spread between 2 compartments. So it is possible to prevent fire spread from one compartment to another along stairways, rooms, some kind of general access corridors, only if all building materials and structural elements share a common fire classification and fire resistant rating. So when we talk about smoke extraction ducting, already the word is saying that we want to extract smoke from the building, and it can be used, it is usually used in large compartments, in parking areas, in office building, high-rise buildings. Also, we had a lot of projects in shopping malls and so on. When we move on, when we move on, fire-rated ducts, this test standard is 1366 part 1. So if we fail with this test standard, it means we cannot test the smoke extraction ducts. So if we pass, then we can test the smoke extraction ducting, and the test standard is 1366 part 8. We call it multi-ducts, and 1366 part 9 as a single ducts. In the next slides, I will tell you how it is functioning, so it would be more clear to you. So let's move on. The classification for the fire-rated duct is 13501 part 3, and for the smoke extraction is part 4. So, and here it's not over. When we talk about smoke extraction ducting, we should have a certificate according to European Harmonized Standard, which is 12101 part 7. When we talk about fire-rated ducts, they are classified as duct A and B. And when we talk about smoke extraction ducts, they are classified as C duct. So let's move on. How do single smoke extraction ducts function? In this picture, it is clearly visible. You see the smoke in one compartment, and the smoke is extracted through the horizontal duct. So single duct can be horizontal, only horizontal, and it is extracted through the shaft, through the vertical shaft. Important thing to know, to mention is, from my experience, when I look to the projects, I don't see any info where it could be written single ducts. Usually it is written, for example, E300, E600. What does that mean? It means that these ducts stands as E stands as for the integrity, and 3 and 600 is the temperature under which they were tested. And when we talk about multi-ducts, how they are functioning, so you see also compartments. So multi-ducts can be done horizontally or vertically. You see the duct in blue, the horizontal and vertical duct, and only at the last compartment we can install single ducts. So if we have, for example, 5 compartments, so for the 4 of them we're gonna use the multi ducts, and only for the last one we can use the single duct. And they are classified as, for example, AE60, AE120. It means that they are tested as for the E stands as for the integrity, and I as for the insulation. Okay, so let's move on to the requirements and procedures of the smoke extraction ducts according to 12101 part 7. Why I'm talking about this standard? You know, in Europe, European countries interpret this standard differently. In some countries, they should have a national certificate. I know that in others, it's enough to have a classification report, EN 13501 part 4, while in Baltics, and especially in Lithuania, we have to follow the harmonized standard, 12101 part 7. I know it very well because for the last couple of years, we've been discussing with the fire authorities, and if we want to deliver certified ducts to the market, we had to follow. We have to certify for this standard, and that's what we did. And here are the procedures of smoke extraction ducting. So it's not only the certificate which we have. but it is also the step-by-step procedures which we have to follow. And I name it 6. So first is certified installers, second is duct installation, third certificates, fourth tightness check, fifth protocols to be filled, and then sixth CE marking. So let's go through all of them, and I will explain it in more detail. First step, certified installers. So what are the key points? The installers, on our case, they are trained in Warsaw. We have a training center where we do the theoretical and practical parts, so that the installers could touch the materials, could cut them, and so on. Then we have installation guideline. It was quite an unusual thing, but this installation guideline was rechecked and confirmed by fire department. And the third is certificate is valid with certified installers. It's very important. So we have certified installers, we have installation guideline, and we have certificates we are using for the market. So the next step is duct installation. So what fixing elements we have to use and cutting tools? In case of cutting, it is quite easy. We use woodworking machinery. In case of fixing the ducts, we use fixing elements like staples or screws. From my experience, I could say that if it is a bigger project, staples, you can do much faster work with using staples. And the ducts or the duct sections are placed on the job site. So you see a couple photos, how they look like. So the installers are making these duct sections, and then they place or install horizontally or vertically, depending on the needs. So the third, we have certificates for the single ducts, and you see you see how it is classified. E600, 120, H stands for the horizontal, 1500 is the maximum pressure. And in our case, we can install ducts in 3 and 4-sided configuration. And in this certificate, you can find detailed information, what kind of board you have to use, maximum dimensions, and even these certificates are in the website of fire department. So you can easily check if we are certified or not. So the certificate for the multi, I have it here also in my hands. So they really exist. You see. So here is as well detailed information about material you have to use, and also multi-ducts can be used vertical, horizontal, and in 3 and 4-sided configuration for the classes A60 and A120. The fourth step is the tightness check. Here are some pictures. We did the testing in fire department, and a couple important things. So tightness check must be always performed when we install the ducting. Special equipment is needed. You see the hose which is put it inside the duct. It should be carefully sealed, and then we perform the testing. Important to note that glue must be always used. It is very important for the tightness. So the fifth steps is protocols. When the installation is done, or during the installation, the installer, the certified installer, are filling the protocols. It's just one example. There's a lot of them which should be filled, controlled, and the installer is sending this all information to us as a producers. The sixth step is C marking. So C label for each fire classes. So for example, if we have a project for 60 minutes and we have in the same project for 120 minutes. So two separate labels we have to use, one for 60 minutes and the other for 120 minutes. Additional, the information, short information about the installer should be placed on the duct as well. So the same six-step example of DOP. We have three different DOP. It's the declaration of performance, or it can be called as the passport of the product. And I just here want to underline some important things that you should look for. It should be written smoke extraction duct sections. You can see the fire class, for example, A60 or A120. And also standards 12.101 part 7 and 13.501 part 4. And the last block of my presentation, I want to share in a couple slides our certified solutions which we have for 3- and 4-sided configuration. So what are the components of the system? From one hand, it seems to be difficult, but from the other hand, when the installer is trained, when they know everything, it's really not so difficult to install these ducts. So the components we use is the boards, calcium silicate boards. Then the glue is important as well. Fixing elements, as mentioned, we fix it with staples or screws. And then there is also other accessories on which is used to hang the duct, for example, horizontally, where they use steel rods, platforms on which duct is placed, and so on and so on. So what we offer to the market today, we have, well, I think it's quite usual, 4-sided ducts, that is clear. And I'm really glad because we are the first in Europe to have certificates according to this harmonized standard for the ducting in 3-sided configuration. Usually when I deal with the participants of the building industry, they are asking, Linus, we want to save space, what shall we do with the ducting? So in such case, 3-sided ducts can be a very good option, but of course there are certain requirements that if we have a duct, for example, A60, so the concrete slab should be also the same fire class with the letter R, so RAE60. And of course, the formation joint should be sealed, certain thickness of the concrete slab should be, and so on and so on. But basically, if we look to how to make the installation, it is quite easy, and of course we are doing the consultations and trainings on the job sites. So here are the certified solutions in the market. So I talked about multi-ducts and I talked about single ducts. So for the multi-ducts, we have for 60 and 120 minutes, we have different thickness boards. And for the single ducts, again, is the same board, but the thickness is much smaller. We use the same board for the smoke extraction, which is Promatec L500. For the cover strips, we use the same thickness as we use as for the whole duct. We tested with ducts for their very huge dimensions, and they can be installed horizontally, vertically. When I talk for the multi, for the single, as mentioned, only horizontally, and in 3 and 4-sided configuration. So, and just couple slides left. I want to show you a couple projects. It will be a mix of the smoke extraction ducts and fire-rated ducts, which we recently implemented in Baltic countries. So here is one of them. It's the shopping and leisure center Acropole in Riga. It is our biggest project in Baltic countries. The 15,000 square meters. You see the ducts were done in horizontally and vertically. Here is additional photos. The installation was done by company CL Fire Stop Solutions, which were trained as well in our training center in Warsaw. One more interesting project, business center in Vilnius. Here it was like a combination of sealing and protecting communications for 3 hours. So this project was, if I'm not mistaken, started in 2018-19. So it went through a couple stages, and it was one of the biggest projects which we did in Lithuania. Here is additional project, medical center in Klaipėda. It was also as the fire-rated duct for 180 minutes. It's not a huge project. It's just a couple hundred square meters, but it is really nicely, professionally done. And I usually get questions: can we paint the ducts? Yes, you can. You can see also in the pictures. But on 98% of the cases, the duct are left without any paint. They have this, how can I say, well, the color is yellowish, like, and the installer is just leaving the duct as it is. But if you want, you can paint it on any color you want, no problem. And the last project is Alpha Shopping Mall, again in Riga. It is our first project where we used our 3-sided configuration ducts. So you can see also we did it vertically. It was done also horizontally, and looks just very, very nice. So I want to thank you for the possibility to have to present my topic. I hope that it was interesting for you. And in case of any questions, if you have any questions on your projects, just let me know. Give me a call or invite to the job site, and we will meet. Thank you.
Thank you very much, Linas. Very interesting presentation. For me, it was quite new and very good to know about all those, even movements in the ducts, because I never knew that one of the crucial things is basically when the smoke duct is, passing through the wall, and those movements can actually make the openings, which can, totally declassify all the systems. So I'm really glad we have some certified solutions for that, and we had a very nice presentation which gave us much valuable information. And with this fine thing, I don't know, how did you like it, Kęstutis, smoke ducts?
Smoke ducts.
Yeah.
Yeah.
as we this is not air ducts, which is this is smoke ducts, and in Lithuanian ortakis and kanalas,
Yeah,
it's
okay.
two different things
Yeah,
here, as we see.
But I would, when you're talking about the presentations, maybe I see the parallels with electric cable and these ducts also,
Yeah.
because it's quite small things influent to the correctly working system, and we usually don't know how to manage that during the building installation process. So it's
Yeah.
very, very important investigations.
Yeah, it's like a Lego. It goes
Yeah.
And we have a next topic, which also will be very interesting to compare with everything that we've heard. It's about gravitational smoke exhaust system. It will be presented by a fire safety expert from SITP Association Poland, Krzysztof Bagiński. It's a very interesting topic about the gravitational smoke exhaust and the hatches itself. What is the situation in Lithuania? Can you describe it in a few words?
Yeah, in Lithuania we have some historical line about the calculation or calculation of the smoke volume which you have removed from the building, and methodology what the equipment we have to use. And there is also mentioned a lot of systems, but one maybe interesting or strange regulations is that we have to have some calculated dependent on the room area. We calculate the openings of vents in roof, and these vents have to be opened by manually. Yes,
manual by hand.
By hand, yeah. So and a lot of questions: who, when, where, how, and right place.
Would you open that? Would you go on the roof and open that?
I haven't this experience.
It's a silly question. I don't understand. Yeah. It's of course very a tough topic, because the ones who have to do it is firefighters.
But I think we're working on that, yes, and we have all ally community to work in Lithuania to improve this regulation. And if we see it's not so good, so we have to propose to change a little bit and in correct way. So I think it will be good.
Yeah. I hope the Baltic Fire Forum will be this platform where fire engineering specialists are gathering, discussing what's the best practice, what's the best methodology, and how can we improve all the fire safety design by itself, per se. So let me introduce Krzysztof Bagiński. We have him right from Gdańsk, Poland. And I hope we shall have some big and fine news. Krzysztof, the stage is yours.
Dzień dobry Państwu, nazywam się Krzysztof Bagiński.
Good morning, ladies and gentlemen. My name is Krzysztof Bagiński.
Moja prezentacja została przygotowana razem z moimi kolegami ze Stowarzyszenia Inżynierów Techników Pożarnictwa, panem Łukaszem Ostapiukiem i panem Pawłem Wróblem.
I prepared this presentation together with my colleagues, Łukasz Ostapiuk and Paweł Wróbel from Fire Protection Engineers Association.
Prezentacja została pokazana, przedstawiona na podstawie wybranych rzeczywistych przykładów projektowych.
We based our presentations on two real-life cases.
Na podstawie których systemy, które zostały zaprojektowane, nie spełniały celów projektowych oraz wymagań oczywiście polskich przepisów.
These two cases do not comply with fire protection standards and Polish regulation in this respect and do not meet the design objectives.
Jest to niestety coraz częstszy przypadek, że systemy oddymiania projektowane są optymalnie, tak optymalnie, że już nie spełniają zakładanych celów projektowych i wymagań normowych i przepisów.
It happens more and more often that the design ventilation system are, so to say, optimized, and by this optimization they are going far from the requirements of the design engineering standards.
Czyli przejdźmy do pierwszego przykładu, ale wcześniej powiemy Państwu, jakie są podstawowe cele systemów oddymiania, które na podstawie właściwego projektu, właściwego zastosowania i później użytkowania będą spełniały odpowiedni cel projektowy.
Before I present you with the first case, I would like to remind you about the design objectives for properly operating and effective smoke ventilation systems.
W każdym standardzie projektowym są podane cele projektowe i przynajmniej jeden z tych celów należy spełnić.
Each reference design engineering standards contains the design objectives. There are many of them, but at least one should be complied with by a fire ventilation system.
Czyli ułatwienie prowadzenia akcji gaśniczej, czyli dotarcie do miejsca pożaru.
So first objective is to support fire suppression and by facilitating the access to a fire engulfed area.
Obniżenie temperatury, czyli możliwość dłuższego przetrwania obiektu w warunkach pożaru.
Reduction of heat, which provides for longer survival of the fire engulfed facilities.
Spowolnienie rozprzestrzeniania się pożaru oraz ochronę mienia.
Another two goals are decelerated propagation of fire and protection of equipment and property in the buildings.
No i oczywiście w obiektach ZL ochronę ludzi.
And of course, when we have the facilities with personnel, then we also provide for protection of people.
Czyli wybierając jeden z tych celów, a być może różne cele, musimy dobrze zaprojektować system oddymiania, żeby mógł spełnić właśnie te założenia.
So at the point of designing the smoke ventilation system, we have to have in mind some or all of these goals to provide for a proper and effective system.
W tej prezentacji pokażemy Państwu dwa rzeczywiste przykłady. Jednym z tych przykładów będzie budynek, magazyn wysokiego składowania.
In this presentation, I will show you two cases. First case will be a high storage warehouse building,
który został wyposażony w instalację tryskaczową oraz system oddymiania grawitacyjnego.
And this building has been equipped with a fire sprinkler system and gravitational smoke ventilation system.
Te rozwiązania były według polskich przepisów z uwagi na powiększenie strefy pożarowej bez ograniczeń.
So in the line of the Polish regulations, these systems were, so to say, unlimited due to enhanced space.
Pierwotny system oddymiania był zaprojektowany według normy amerykańskiej NFPA 204.
Original technical documentation of the building said that the smoke ventilation system was properly designed in compliance with NFPA 204.
W celach projektowych tego pierwotnego systemu była ochrona konstrukcji obiektu.
So the design objectives were protection of the building structure,
zmniejszenie strat pożarowych,
reduce damage caused by fire extinguishing action,
ułatwienie ewakuacji osób z obiektu,
easier evacuation of personnel from the building,
oraz ułatwienie prowadzenia akcji ratowniczej.
And support for firefighters in efficient fire extinguishing and rescue action.
Ten budynek miał powierzchnię około 7000 m2.
The building area was about 7,000 square meters.
Miał wysokość około 20 metrów.
And it was around 20 meters high.
Oraz wysokość składowania obiektu była 15,4 metra.
And the warehousing height was 15.4 meters.
Pierwotny projekt zakładał jedną strefę dymową.
The original design provided for one smoke control zone.
Wysokość warstwy dymu była na wysokości 8 metrów.
And the smoke layer was at 8 meters high.
Moc pożaru była określona z uwagi na dojazd Państwowej Straży Pożarnej w czasie 900 sekund.
The heat release rate was taking into account the access for the State Fire Brigade, and it was established at 900 seconds.
A uruchomienie klap w pierwotnym projekcie było z uwagi na pęknięcie ampułki, czyli termozwalaczy w klapach dymowych.
And the smoke vents were triggered by the breakage of temperature bulb with alcohol, which was installed in these smoke vents.
Termowyzwalacze w klapach dymowych miały 91 stopni Celsjusza.
Thermal trips in sprinkle installation were set around 71 degrees centigrade.
Czyli generalnie oceniając już pierwsze założenia tego projektu,
So when we evaluate the basic assumption of the design,
generalnie były niezgodne ze standardem projektowym.
we see that they were incompliant with the design standard.
Przede wszystkim moc pożaru powinna być określona z uwagi na uruchomienie instalacji tryskaczowej.
So the heat release rate, first of all, should be based on the time of the reaction of the sprinkler installation.
Termowyzwalacze w klapach powinny być o temperaturze w granicach od 121 do 172 stopni.
So triggers in that installation should be activated at within the range of temperature from 120 to 180 degrees centigrade.
No generalnie przy takim układzie prawdopodobnie te klapy nigdy by się nie otworzyły.
Generally, with these settings, those smoke vents would never open.
W pierwotnym projekcie zostały zastosowane 4 klapy dymowe o wymiarach 1,6 na 1,6.
The original design provided for 4 smoke vents, each one measuring 1.6 to 1.6 meters.
Czyli generalnie powierzchnia geometryczna klap wynosiła 9 metrów kwadratowych, dla obiektu 7000 metrów kwadratowych.
So the geometrical surface for the whole area was 9 square meters for a 7000 square meters floor area.
Ten obiekt nie został przekazany do użytku, bo zgłosiła do niego zastrzeżenia Państwowa Straż Pożarna.
This facility has not been handled for use and not accepted because of the reservations made by the State Fire Brigade.
Ten obiekt został przeprojektowany.
The facility had to be redesigned.
Standard, system odymienia również został zaprojektowany na podstawie normy amerykańskiej NFPA 204.
The revised design was also based on the NFPA 204 standard.
Obiekt został podzielony na 2 strefy dymowe i w każdej z tych stref zastosowano 18 klap dymowych.
The revised design provided for 2 smoke control zones with 18 smoke vents each.
Zgodnie z założeniami inwestora powierzchnia, wysokość warstwy dymu była powyżej materiałów składowych.
So according to the assumption by the investor, the smoke layer height was above the level of storage.
Z uwagi na wielkość obiektów zostały zastosowane również dodatkowe otwory napowietrzające w sąsiedniej ścianie.
Due to the size of the facility, there were some air intakes made in one of the walls.
W celach porównawczych wykonaliśmy analizę numeryczną CFD rozprzestrzeniania się dymu i ciepła.
So in order to compare the designs, we performed the analysis of the CDF analysis.
Wariant 1 pokazuje pierwotnie zaprojektowany system oddymiania.
Option 1 shows us the originally designed smoke ventilation system.
A wariant 2 oraz 3 po przeprojektowaniu systemu.
And the option 2 and 3 show us the situation after the redesigning of the original system.
W trakcie tej analizy pokazaliśmy tutaj uruchomienie klap dymowych po zadziałaniu instalacji tryskaczowej przy 180 sekundach i po 60 sekundach.
During that analysis, we showed the cases of operating the smoke ventilation after the trigger of fire sprinklers, and this trigger was after 60 seconds and after 180 seconds.
Jak widzicie Państwo, w celach projektowych tego pierwotnego systemu była ochrona mienia.
As you can see, one of the original design objectives was to protect property that is stored inside the warehouse.
Jak widać na tym diagramie, realizacja tych celów w ogóle nie została osiągnięta.
As you can see in the option 1 diagram, those goals have never been achieved.
Ponieważ było oddziaływanie temperatury w całym obiekcie.
Because there was the high temperature effects could be observed in the whole facility.
Patrząc na wariant 2 i 3 po przeprojektowaniu systemu,
when we look at the option 2 and 3, which is after the redesign of the system,
możemy zauważyć, że kurtyna dymowa, która została zastosowana, ogranicza rozpływ temperatury po całym obiekcie.
we can see that the smoke barrier is limiting the propagation of high temperature all over the facility.
Bo tak jak widać, odległość od kolumny konwekcyjnej, ta odległość powoduje, że ten dym może się obniżać.
The distance from the convection column allows for lowering the level of the smoke.
Na dalszym diagramie pokazujemy Państwu zasięg widzialności w poszczególnych wariantach projektowych.
Another diagram serves to show you the visibility range in the design assumptions.
Widać, że pierwotnie zaprojektowany system nie mógł spełnić zakładanych celów projektowych.
As you can see, the originally designed system could not comply with the design objectives.
Określiliśmy także, porównaliśmy wyniki dla poszczególnych wariantów izopowierzchni dla wartości współczynnika 0,8, czyli widzialność obiektu z odległości 10 metrów dla obiektów emitujących światło.
We also make comparison for the two design assumptions and the spread of the smoke for the coefficient at 0.8, which means the visibility range of 10 meters.
Możemy tutaj zauważyć jeszcze, że uruchamiając system w granicy 60 sekund po zadziałaniu instalacji tryskaczowej jest mniejsza możliwość przemieszczania się dymu do sąsiedniej strefy i większa ochrona mienia.
So we could also observe that when the smoke vents are operated 60 seconds after the trigger of fire sprinklers, we reduce the possibility of spreading and propagating smoke to adjacent zones.
Kolejny realny przykład projektowy.
Another real-life case.
Był to obiekt magazynowy wysokiego składowania o wysokości 12 metrów.
It was a high storage warehouse of approximately 12 meter high,
który nie był wyposażony w instalację tryskaczową oraz system sygnalizacji pożaru.
The facility was not equipped with a fire sprinkler system or a fire alarm system.
Według przepisów system oddymiania miał służyć przede wszystkim obniżeniu temperatury.
The smoke ventilation system was supposed to reduce the temperature first of all.
W celu przyjazdu jednostek Państwowej Straży Pożarnej.
It was in order to support the fire brigade in their appearance on the spot.
Pierwotny system oddymiania został zaprojektowany według normy amerykańskiej NFPA 204.
Original ventilation system, smoke ventilation system was purportedly designed in compliance with NFPA 204.
W celach projektowych projektant przyjął ochronę konstrukcji obiektu.
And the design goals were as follows. First, protect the building structure.
Zmniejszenie strat pożarowych.
Secondly, reduce damage caused by fire extinguishing action.
Oraz ułatwienie prowadzenia akcji ratowniczej Państwowej Straży Pożarnej.
And the third, facilitate efficient fire suppression and rescue action by firefighters.
Możemy na tym obiekcie, na tym diagramie zobaczyć ten obiekt. Powierzchnia strefy w pierwotnym projekcie wynosiła 4000 m².
This diagram shows us the facility. The original design provided for a surface area around 4,000 square meters.
Według normy pierwotnego projektu było zaprojektowanych 14 klap dymowych, uruchamianych tylko i wyłącznie z termowyzwalaczy.
The original design provided for 14 smoke vents opened locally when triggered by a temperature rise.
Możemy na tej planszy zobaczyć podstawowe założenia w pierwotnie zaprojektowanym systemie.
This slide shows us the original assumption for the originally designed smoke ventilation system.
W celach projektowych było określone ochrona mienia, a wysokość warstwy dymu według projektanta była na wysokości 3,2 metra od posadzki.
The purpose was to protect the property that was warehoused, and the planned smoke layer thickness was at 3.2 meters from the floor level.
A wysokość składowania w obiekcie była do 9,5 metra.
While the actual material storage height was at 9 points.
Czas dojazdu do obiektu i możliwość rozpoczęcia działań ratowniczych była w ciągu 900 sekund.
Time from efficient ignition after incubation and the time for the appearance of the fire brigade on the scene was 900 seconds.
I możemy do tego zgłaszać uwagi, ponieważ nie był obiekt wyposażony w system sygnalizacji pożaru z przekazaniem do jednostek ratowniczo-gaśniczych.
We can have some doubts about it because there were no automatic fire alarm system that would inform directly the fire brigade about the fire.
Więc przyjęcie takiego założenia jest oparte dużą wątpliwością.
So to adopt such assumption for the design is very dubious.
Ten system można byłoby zaprojektować, ale projektując na podstawie pożaru o stałej mocy.
This system should work, but in case we have a heat release rate at the stable level.
Ale wtedy musielibyśmy zachować duże granice pomiędzy składowanymi materiałami z uwagi na moc pożaru.
But in such case, we have to keep quite a large distance between the stored goods in order to comply with such a heat release rate.
Dodatkowo ten pierwotny projekt był tak zaprojektowany, że uruchomienie klap dymowych termoizwalaczy nie powodowało otwarcia automatycznego otworów napowietrzających.
Additionally, the system did not provide for automatic open of the air intake vates after the opening of smoke vents.
Co jest całkowicie niezgodnie z normą, bo według normy NFPA klapy otwory napowietrzne powinny być stale otwarte albo powinny się uruchamiać automatycznie.
It is totally non-compliant with the NFPA because according to this standard, the air intakes should be open all the time or should open automatically after the smoke vents are triggered.
Pierwotny projekt został przeprojektowany w oparciu o normę polską.
So the whole facility was redesigned based on Polish standards.
Pomieszczenie zostało podzielone na dwie strefy dymowe.
So the second design provided for two smoke control zones.
W każdej z tych stref była powierzchnia czynna odymiania wynosząca 3% przestrzeni poddachowej.
So each of the zones provided for 3% smoke ventilation space under the roof.
Kurtyna dymowa pomiędzy strefami dymowymi powinna być zaprojektowana do wysokości 8,5 metra.
The smoke barrier should reach up to 8.5 meters.
Ale z uwagi na wymagania technologiczne inwestora już w zastanym obiekcie kurtyna musiała być zaprojektowana do wysokości 9,6 metra.
But due to technological limitations that has been assumed by the investor, the smoke barrier reached up to 9.6 meters.
W nowym projekcie klapy dymowe były uruchamiane po uruchomienia ampułki alkoholowej, ale otwierały też pozostałe klapy dymowe w danej strefie.
In the new designs, the smoke vents were opened after the breakage of the alcohol-filled temperature bulb, but at the same time, they caused the opening of all the smoke vents in a given smoke control zone.
Możecie Państwo zobaczyć tutaj schemat blokowy sterowania.
You can see the block diagram for the control of the smoke vents.
Nowo zaprojektowanego systemu.
Within the newly designed system.
W klapach dymowych zostały zamontowane wyłączniki krańcowe, które miały uruchamiać pozostałe klapy oraz otwory napowietrzające.
The smoke vents were equipped with limit switches that were causing the opening of the rest of the smoke vents in the given smoke control zone and the pressurized air intakes.
Niestety to rozwiązanie też nie jest idealne, ponieważ przy dużej generacji dymu a niskiej temperaturze
this solution is not ideal either because in the high condensation of smoke and the high temperature.
Więc w takich sytuacjach, kiedy będzie taka sytuacja, część klap może się po prostu nie uruchomić, a dym może być już na posadce.
In such a situation, some of the smoke vents may be immobilized, blocked, while the smoke reaches the floor level.
Lepszym rozwiązaniem w takiej sytuacji powinien być system wykrywania dymu lub system sygnalizacji pożaru.
A better solution would be to apply fire detection system or fire alarm system,
który przy niskiej temperaturze szybko uruchomi klapy dymowe i otwory nawietrzające.
That would trigger the smoke vents and air intakes even at the lower level temperature.
Na tym schemacie jeszcze możemy zobaczyć, kiedy w obiekcie będzie instalacja tryskaczowa.
This diagram also shows the situation where there is a sprinkler installation within the facility.
Z poprzedniego przykładu możemy to zauważyć, jeśli uruchomi się instalacja tryskaczowa, daje sygnał do centrali oddymiania.
When the sprinkler system is activated, it sends a signal to the central control of the ventilation system.
I również wtedy będziemy otwierać klapy w odpowiedniej strefie dymowej, gdzie uruchamia się instalacja tryskaczowa oraz otwory napowietrzające.
And in such case, the smoke vents for a specific smoke control zone will be opened together with pressurized air intakes.
A dodatkowo możemy tu jeszcze zobaczyć na tym diagramie, skoro możemy otwierać klapy do wentylacji.
And this diagram shows us when in a situation when we can open the smoke vents.
Wówczas, jeśli jest instalacja tryskaczowa, to klapy powinny być zamknięte, czyli najpierw system detekcji wykrywa dym, zamyka klapy.
And in this case, when we have sprinkler installation, the smoke vents remain closed. For instance, the system detects this smoke and closes the smoke vents.
I dopiero po zadziałaniu instalacji tryskaczowej uruchamiamy klapy do oddymiania i otwory nawietrzające.
And only after the sprinkler installation is triggered, the smoke vents are opened together with air intakes.
Patrząc na ten diagram, drugi przypadek projektowy był właśnie tak zaprojektowany, czyli
when we look at the diagram, we can see that the second case was designed in this way.
Czyli klapy uruchamiały się albo ręcznie, albo poprzez uruchomienie termowyzwalaczy w klapach.
Smoke vents were either manually operated, either triggered by the thermal trips.
A otwory napowietrzające tylko poprzez uruchomienie ręczne.
And the air intakes were operated only manually.
Czyli jak widzimy na tym zdjęciu, bardzo często dostanie się do obiektu będzie powodowało, że straż będzie musiała te otwory wyciąć albo je otworzyć.
So as you can see in this picture, such a system makes it more hard for the fire brigade to enter the scene because they will have to cut out the intakes or the openings for them.
I w celach porównawczych wykonaliśmy analizę CFD rozprzestrzeniania się dymu i ciepła dla tych dwóch przykładów projektowych.
For this case, we performed the CFD analysis for heat and smoke propagation.
Dla tego pierwotnego projektu oraz dla nowo zaprojektowanego systemu.
Both for the original design and for the newly prepared design.
Jak tutaj Państwo możecie zobaczyć rozkład temperatury do czasu 1200 sekund.
There you can see the distribution of temperature up to 1200 seconds.
No widać, że klapy dymowe, ponieważ są uruchamiane tylko z termowyzwalaczy, więc nie wszystkie są w stanie się otworzyć.
Because the smoke vents are activated by the thermal trips, not all of them could be opened.
Jest temperatura, ponieważ z uwagi na uruchamianie tych klap wysoka temperatura jest na znacznej części obiektu.
And due to that fact, we have the high temperature at the major part of the facility.
Czyli generalnie cele projektowe jakby były ujęte w projekcie nie zostały zachowane.
So the design goals have not been complied with.
Po przeprojektowaniu systemu
When the system is redesigned,
widzimy tutaj dwie strefy dymowe i kurtynę dymową, która nie mogła być odpowiedniej wysokości.
we can see two smoke control zones divided by a smoke barrier that could not be high enough.
Ale już z uwagi na otwarcie pozostałych klap w strefie otworów nawietrzających,
But due to the fact that the smoke vents were opened together with air intakes,
system został właściwie zaprojektowany, bo warstwa dymu nie wchodzi na materiały palne.
we can see that the system is properly designed because the smoke layer is not interfering with the stored materials.
Występują przecieki do sąsiedniej strefy dymowej,
There are some leakages to the adjacent smoke control zone,
ale z uwagi na to, że nie mogliśmy wykonać właściwej kurtyny dymowej.
but it is due to the fact that it was impossible to build a smoke barrier with a proper height.
Jak widzimy na tym diagramie, występowanie wysokiej temperatury zostało znacznie ograniczone.
As you can see in the diagram, the propagation of high temperature was substantially limited.
Czyli jest jedna ważna rzecz, czyli właściwe uruchamianie systemu oddymiania daje dużą pewność zachowania właściwych celów projektowych.
So there is one thing we have to emphasize. If you properly design the smoke ventilation system, you can meet your design objectives.
Przejdźmy do podsumowania.
So let's go into the conclusion.
Jak widzicie Państwo, oczywiście wiemy, że zastosowanie instalacji tryskaczowej w magazynach składowania jest najskuteczniejsze.
Of course, we are fully aware that the installation of a sprinkler system is the most effective way of protecting against the smoke propagation and fire.
Ale jednak nie upoważnia to do projektowania systemów oddymiania nieuwzględniających celów projektowych
But the
oraz
mere
założeń norm.
existence of fire sprinkler system does not allow for any design of an effective smoke ventilation system which do not comply with reference standards and regulations.
W magazynach zastosowanie właściwie zaprojektowanego systemu oddymiania może spełnić cele projektowe wynikające z przepisów oczywiście danego kraju oraz założenia normowe, które jesteśmy w stanie osiągnąć.
The use of properly designed smoke ventilation system will always help us to comply with the valid design standards and to achieve the design goals that are provided for in any local regulations.
I jak wiemy z doświadczeń badawczych, wyzwolenie jednej klapy nie jest zadziałaniem całego systemu. Wszystkie standardy projektowe mówią, że żeby skutecznie ochronić daną przestrzeń, daną strefę dymową, trzeba otworzyć klapy dymowe.
Of course, opening or activating one smoke vent is not tantamount to the proper protection of the area. In order to provide proper protection, we have to open all the smoke vents that are assigned to a specific smoke control zone.
Brak zrozumienia zasad projektowych oraz celów projektowych, które przyświecają w systemach, oraz czasami projektowanie tak systemów, żeby robić je jak najbardziej optymalnie, no powoduje, że te systemy zupełnie nie są skuteczne, tak? Nie spełniają wymagań ani przepisów, ani założeń normowych.
The lack of understanding of design calculation principles and and as well as negligent or sometimes intentionally wrong application of reference standard calculation in order to optimize the system result in non-compliance with the design objectives, and it makes those smoke ventilation systems totally ineffective.
Musimy zwrócić uwagę, żeby właściwie skorelować działanie systemu oddymiania oraz instalacji tryskaczowej.
We have to correlate properly the operation of the smoke ventilation system and the sprinkler system.
Czyli uruchomienie klap dymowych po odpowiedniej zwłoce czasowej.
It means that the smoke vents should be opened after appropriate delay, which is subsequent to the triggering of the fire sprinkler system.
Zwracamy jeszcze uwagę na stosowanie kurtyn dymowych, które są bardzo istotnym elementem w projektowaniu systemów oddymiania.
We would like to draw your attention also to the issue of building smoke curtains or smoke barriers, which are a very important element of the fire and smoke protection.
Ponieważ ograniczają rozprzestrzenianie się dymu oraz ciepła na cały obiekt.
Because they stop the propagation of high temperature and smoke all over the facility.
Oraz powodują, że system działa sprawniej.
And increase the efficiency of the whole system.
Jeszcze musimy tak zaznaczyć, że generalnie jeśli nie mamy instalacji tryskaczowej, czyli najlepszym rozwiązaniem do uruchamiania systemu oddymiania powinien być albo system wykrywania dymu, albo system sygnalizacji pożarnej.
If there is no sprinkler installation, we have to have in mind that in order to protect the facility, we have to provide for the smoke detection system and fire alarm system.
Tak jak wcześniej powiedziałem, nie każdy pożar generuje dużą ilość temperatury.
As I said before, not every fire generates very high temperatures.
Szczególnie w obiektach wysokiego składowania i wysokich obiektów.
Especially in very high buildings and high storage facilities.
Więc wówczas część klap z termowyzwalaczy po prostu się nie uruchomi, nie spełni celów projektowych systemu.
In such case, some of the smoke vents will not be activated and the design objectives of the system will not be complied with.
No i oczywiście otwieranie otworów napowietrzających, które jest ważne dla każdego systemu oddymiania, czy grawitacyjnego, czy mechanicznego.
All smoke ventilation system rely on the air intakes, regardless if it's a gravitational system or automatic one.
Czyli musi być automatyczne. Otwieranie otworów napowietrzających musi być automatyczne.
This calls for an automatic opening of the air intakes.
No i to też daje szansę jednostkom ratowniczo-gaśniczym na szybsze dotarcie do obiektu i możliwość skrócenia czasu działania.
This also gives better access to the fire engulfed spaces for the firefighting brigades and gives opportunity to shorten the time of fire and related dangers.
Dziękuję Państwu bardzo za wysłuchanie mojej prezentacji.
Thank you very much for your attention.
Dziękuję bardzo.
Thank you.
So thank you very much, Krzysztof. Very nice presentation. I mean, I think lots of people will get lots of new information about that. This best practice from your side is, I think, will be very useful, not only for Lithuania, but Latvia, Estonia as well. And we shall try to see our own codes and try to improve and be better and better each day. What we seek further is basically the, as we call it, the Grenfell topic, yeah, the facades, which the Grenfell Tower fire was the eye opener for everybody in Europe. Though we had lots of fires right before, Emirates and some other countries, states, whatever. There are facades. There is the same problem. The next our presenter will talk about Polish way of best practice, the evaluation of neighbor countries, the evaluation of their fire codes, which describe the facade flammability classes and how to design them. I'd like to ask you, Kęstutis, what about this issue in Lithuania? Is it an issue? Is it a problem? What is your point of view in that?
Yeah, it's very, very, how to say, sad point of our experience. Lithuania is not, how to say, one of the countries who is in this situation, I think, because the facade topic in the world, you have a lot of discussions in fire safety specialist community. And as example, at the moment we haven't any regulation or test methodology from the European Union. It is not harmonized scope. So and in this case we can't test correctly these materials in the right way. So and in Lithuania was done some part of test after the fire in London and other fires also, and the results of these tests was
quite sad, I'd say. Yeah,
quite sad. I've
heard these rumors in the construction companies area that oh my God, we are taking off and then testing once again the facades.
Correct. And about the 60% of the facades that was tested do not confirm the flammability class was declared. So it's and in sometimes a little bit, but in biggest part of the cases it was the quite huge difference. And it's very difficult, how to say, to control that and to obtain that, because the materials, facade materials, looks very similar, and one is fire resistant and another not. So and how to check it and how to recommend to other specialists, not fire safety specialists, who are just buying these materials and installing. So it's very, very, very big question in Lithuania.
So it's taking off the elements, let's say, and testing them in laboratory. If you could do this, let's say, during the construction process, would it be too much of bureaucracy, or would you think that this would be the right way, just to have 100% sure that you are buying the right thing?
Normally, I will say that is huge bureaucracy to check, to do, to have permission and so on, to go everywhere around to implement this. But in this case, I'll take a little bit position that is not. This checking takes us, as our experience shows, takes us a little bit more knowledge, practice, and understanding the problem of whole construction community, of all construction people who are building these buildings. So.
Okay, nice, thank you. So our next presenter is the representative of SITP, accredited laboratory, Daniel Małozieńcz. So Daniel, we wait for your presentation, and best regards there in Warsaw.
Good afternoon. My name is Daniel Małozięć, and I'm an employee of Scientific and Research Center for Fire Protection, National Research Institute in Józefów, Poland. I work in Combustion Process and Explosions Lab. Among others, our institute carry on fire tests of constructive products for different purposes. It means to get knowledge about their fire properties, to demonstrate compliance of their properties with domestic and European regulatory requirements, etc. I'd like to talk about best practices in design fire safety of facades in Poland. In our country, every year, more and more buildings are insulated with use of external thermal insulation composite system, later called ETICS. In most such solutions, the insulating material is expanded polystyrene. A brief overview over fire statistics from Poland at the beginning. In 2019, there were over 150,000 fires in Poland, and those fires caused about 500 victims and 4,000 injured, and generated losses over 2 billion zlotych. About 32,000 of those fires were in residential buildings, and 16,000 were in single-family houses. The number of fires in residential buildings where facades with combustible ETICS were involved is growing. What are the Polish regulations on the spread of fire on external walls? In addition to various specific requirements for various constructive products and materials used to interior finishing, in Polish regulatory requirements, there are requirements relating to facades. Building elements of most of the building shall be non-spreading fire. It's NRO in Polish requirements. For walls and their claddings, NRO requirements and test methods differ depending on the site of the fire hazard and the place of product installation. When we are talking about fire risk from inside the building, reaction to fire classes A1, A2, and most of B classes should be achieved. And when we are talking about fulfilling no fire spreading NRO criteria in test against the fire from outside the building, the tests have to be made according to Polish standard PNB 02867. Generally, in all buildings at a height above 25 meters from the ground level, the facade cladding and its mechanical fastening, as well as thermal insulation on the external wall, should be made on non-combustible materials. A few more words about the Polish test, the Polish requirements. A test of facades according to requirement of this Polish standard, which is titled A Method of Testing the Degree of Fire Spread from the Outside through External Walls and Classification Rules, is mandatory test in Poland. This is a bench scale test where tested ETICS is fastened to the wall with a dimension of 1.8 by 2.3 meters. There is no window in the tested sample. The fire source is 20 kilos of wood, which is positioned in front of the wall, and the source of ignition of the wood pile is 0.2 liter of heptane or ethanol. In front of the wall, there is also a fan which provides airflow at speed 2 meters per second at the top of the pile. The test starts when the ignition of heptane. 120 seconds after ignition, the fan is turned on. Testing time is 30 minutes and it is divided into two parts. The first part of the test ends after 15 minutes, and then the burning pile is moved away and the fan is turned off. The second part is observation of the tested product after removing the source of the fire, and it also takes 15 minutes. The classification is based on the maximum value of temperature in measuring points on the line L1 and L2, which you can see on the figure. Occurrence of flaming combustion in the lines L1 and L2, and presence of flaming droplets or flaming solids. Based on my experience with testing of such system, if the sample is well prepared to the test, normally it will pass the test. It will pass the test. Some information about real fires in Poland. This is a film from a fire in 10th floor buildings. Fire started on the 4th floor. There were 1 fatal victim, 4 injured. A lot of people have to be evacuated, and a lot of flats needed renovation. As you can see, the fire is very intensive. Flames come out of the window, and this situation shows that proper protection of flammable parts of facades is very important. The next film from real fire, probably the cause of this fire was probably the ignition of old furniture, which were stored in front of the facade. During a couple of minutes, fire passed 11 floors of the facade and reached the roof. Because of temperature, some windows were damaged and fire entered to the building, and smoke fulfilled the escape route. In this movie, we can see very fast spreading of the flames from ground level through all floors to the roof. Such fast spreading of fire points to errors in installation of the ETICS system. A few more photos from real fires in residential buildings. Another one, single family house, completely destroyed. And another film. It is a film from fire of residential complex under construction. The cause of the fire was carelessness during some construction work on the roof. On the upper film, we can see the fire, and on the lower, there is a damage after the fire. As you can see, the problem with spreading fire across facades is serious. In 2018, Association of Fire Engineers and Technicians, with help of fire experts, people from fire labs and insurance company, prepared guideline fire safety of facades with ETICS. The aim of this document is limiting the spread of fire on facades. The guideline contains rules limiting the risk associated with ETICS system with combustible insulation, especially factors which are not covered or not fully covered by our national regulation, mean this Polish standard which I talked about earlier. In the guideline, there are some figures and details which describe the minimum safety measures. In the opinion of the authors, recommended solutions are available on the market and have limited impact on the total cost of mounting of such system. To whom such guideline is dedicated to? It's dedicated to designers, constructors, fire experts, and investors. What are the proposed ways of balancing the risk of combustible materials on the facades described in the guideline? They are based on two ways of limitation of fire spread on facades. One based on materials and technologies. It means reducing the amount of combustible materials, increasing the thickness of the top layer, or using high quality of installation. The second way, as a structural measure, mostly it's fire barriers with non-combustible materials in combustible insulation. In the next few slides, I will try to show some examples of the recommendation contained in the guideline. First, we need to identify which places need additional protection. When we need to protect the facade against the fire from inside the building, we have two situations. The first one, the facade is with some windows, and the second one is just wall. When we have window, we have to protect almost all facade, especially the contact places of window with the facade. When we don't have any window, we don't need to protect the facade against the fire from inside the building. And when we need to protect the facade against the fire from outside the building, it's quite different situation. As you can see, the authors propose that the additional protection should be added to the first 3 floors and next to the roof, if the roof have combustible materials. The same requirements are described for the facade with windows and without windows. There are different requirements. There are proposed different requirements depending on the thickness of the layer of combustible material and the risk of spreading of the flames. The guideline proposes the following solution. For example, the first one is for system with a polystyrene thickness less than 10 centimeters. The guideline proposed some fire barriers in the form of non-combustible mineral wool stripes. The green color means the place where fire barrier should be installed. The first one next to the ground level over the plinth. The second one between first and second floor. The next one over the third floor. And the last one next to the roof. When the ETICS system is with polystyrene with thickness less than 10 centimeters, there are no need to install additional fire barriers between third floor and the roof. But when we are talking about polystyrene insulation with a thickness greater than 10 centimeters, such requirement is added to the guideline. The rules are almost the same with additional stripe of mineral wool made every 2 floors between third floor and the ground and the roof level. Of course, there is a possibility to make a protection of facade in a different way. On the second figure, there is such proposal. There is only requirement to protect the window. In the guideline, there are more such features which in details can explain how to do the barrier. For example, if we have windows, there will be different proposed protection layer when we have the window installed in the insulation layer, and quite different when we have window installed in the solid, for example, concrete or ceramic layer of wall. There are, of course, described some extra protection rules which are used for other zones which should be protected. For example, for loggia ceilings, for area under the lightning protection system, for ceilings and undercuts, and wall next to usable terrace or roof. At such wall, the protection should look like the walls on the ground floor. The aim of the guideline is to improve the fire safety of building with combustible insulation by limiting the risk of fire spreading along the facade to other stories of the building. Two ways of limitation of fire spread on facades are described in the guideline. One based on material and technology, and the second based on the fire barriers made from non-combustible materials. Recommended solutions are available on the market and have limited impact on the total cost of ETI-CS system. During preparing the guideline, the author also used the best knowledge contained in instruction already implemented in other countries. There are some examples of similar fire guideline in other European countries. Such document looks like this. It's about 36 pages with detailed description and figures of proposed solutions. Thank you very much for your attention.
Thank you very much, Daniel. Very interesting topic, very recent topic, and actual all the time. I think we shall have some really new information, especially from the other countries. This best practice guidelines is always very much interested. Talking also about changing or improving fire safety strategies at all for our national buildings. So in this case, we always go back a little bit and find for a good retailer who could give us also good technical news about how to implement the passive fire safety systems. And here I'd like to invite Viljar Cedric, our neighbor from Estonian, and he's a representative and CEO of a company Genoke, which will show us also the most innovative intumescent films for steel constructions. They will show us wood protection, and they will show us fire sealing and fire stopping systems. These are the basic and very important elements of passive fire safety strategy inside the building. So we need to structurize and limit the performance of fire every time when it occurs in the premises of inside the building. So, Viljar, the stage is yours.
Hello, my name is Viljar Sedrik, and I'm Managing Director of Passive Fire Protection Materials Distribution Company of Genoke Trading. I would like to present for you with this short time capabilities of Genoke Trading and how we are able to support you and your customers now and in the future. Okay, shortly about our company. We are in the business already from 1996, and today we can say that we are active in all Baltic states and Scandinavia countries as well. We are official distributors or partners of all main passive protection brands in EU and of course already outside of the EU as well. We are members, of course, of different associations and working groups in our area, and to offering for our customers and clients more better service and support. Then we have now our own technical support and engineering team who is well skilled and trained and who are we can say almost every day in direct contact with our partners and producers technical teams. So we can give for you and for your customers the quickest and professional support. Then to be close to our customers and to get the best service. We have local managers and warehouses in all Baltic states and from beginning of this year also in Finland. We have totally today more than 2,000 square meter of stockroom, and I can say that it's growing. Then I look at last year that we sell out more than 40 full trucks of different passive fire protection materials. And I think it proves that we know what we are doing. Then maybe what is our main and the most important strengths is we try to hold always the main needed products in our stock, and because that's why so we can offer for our customers over the market in Baltics and in Nordic countries short delivery times. And today we can say it's normally it's 24 till 72 hours. Of course, sometimes are some special reasons, maybe longer, but generally It's not more than 72 hours. Yeah, this is a short overview about our company. Then to understand to understand how much partners we have and why we working like this, I need to explain that like I said, we working in Nordic countries and also in Baltic market. Then it's necessary to understand that the markets are a little different. Generally, if in Baltic market today still it's common that our customers who are generally fire protection installation companies going to the construction site to seal the penetrations or making the fire protection work when already the building is not ready but ready enough, and when the communications are already installed, the pipes and cables already are installed. And in Baltic states, we still have problems that fire protection works are not planned and put into the project before building activity started. And that's why we have a lot of requests and problems from our customers because they need to solve the situations what pipe and cable and so on installers are made for them. Example, very often the holes are too big. Maybe the cable bundles are not enough in standard and so on. Just very simple. It's very common in our business that our customers just don't find solutions from installation manuals, and that's why we need to work close together with different partners in our region, and because we need to offer for our customers the best solution, and they need to finish the work. Totally different situation is in Nordic countries, because there is already everyday how to say experience that they planning fire protection works before they starting building activity. And in this case, it's much simple to support the project and find together with engineers and designers the best solution for projects. And later, it's very simple. We just can deliver the products for the projects. But in Baltic states, it's going like together. We try to find solution like the case by case, and then we need to find products and deliver the products. That generally we can say that to be flexible, to give best options for our customers, we need different brands and partners in our toolbox. Because today is the situation that nobody can't cover all needed solutions, and that's the reason. Okay, let's move on. Then that was a short overview about Kenoke trading and what we are doing and how we are doing. Of course, now I have limited time to present for you maybe some new products or some solutions what are popular for our customers and different markets. Like I said, the time is limited, and I just choose a couple main interesting things what I would like to present for you. And yeah, let's move on with this. Okay, like you know that if you are active in intumescent coating business, then always the problem is time, also weather condition in our region, and of course more and more in Nordic countries also ecological products, that's mean low VOC products. Then today, if we need to Nordic markets low VOC products, we have to use normally water-based one component intumescent paints. But of course, what is the problem with this is, of course, the drying time is long, and also we need to protect always the water-based coating against weather. That means that if we have like the painting activity in construction site, then we need to do it normally on the floor, on the roof, and this is of course limit for us, and sometimes it's very difficult to protect it the paint during the drying time against the weather, and also sometimes if the construction site box, we can say, is open, we need to put the top coat as well. This is like I know one of the biggest problem for our customers. Second option, of course, is to make the painting work in shop, in factories. But there is also factory time is costing. Also, the second problem is even the building is or the steel going to the inside later. Then especially for transportation is necessary to protect the water-based intumescent with top coat, and especially in Baltic states, very often the steel going over the sea to Nordic countries, and again we have a lot of problems. Sherwin-Williams have created no solution for these problems. They call it Firetex FX 6002, and this is fast drying, even ultra drying intumescent paint. It's even 3-component paint, but like you can see that it's ready for handle already with 2 hours, and it's possible to get with this paint very long durability time. Even 20 years is no problem with special top coat. Then of course this is future product, especially in the Baltic states. I can say I know that it's already more and more popular in Nordic countries, but I think it's important to know for you and for your customers, because sometimes everybody we know that time costing money, and sometimes the time is most expensive for us. Then I think it's for you important to know that now we have this kind of solution for previously mentioned problems. I have added here also one link from YouTube, what is presenting this product. Then you can take the time and take a look at the product. Okay, let's move on. Okay, traditionally we have protecting concrete against the fire with mineral wool, like you know. But in the modern world, more and more people and building owners want to be more healthy and looking to have solutions what are simple to install and what is more healthy and making maybe less allergens and so on. Already couple years we have requests and problems from customers that previously installed mineral wool is one point is already out of service now and it's necessary to replace, but the general problem is that after installing of mineral wool, it's not very stable long time and the dust, the wool dust coming very easily to the living rooms and people don't like it anymore. And the last couple years, now we have a good practice with the new product. This is Amotherm brick and the second one is Amotherm concrete from Amon. And this is very good and more popular solution for customers to replace previously installed fire protection stone wool. And because it's one component water-based intumescent paint, of course with low VOC. It's very simple to install. It's even every installer who have experience with regular intumescent paints are able to do it. And of course, if it's necessary to get to the room some special color or tones, then we can offer special top coat for this. Then at the moment, it's very popular in Nordic countries, and also we have a couple important projects already in Baltics as well. Then I think it's also important to know that we have this kind of solution now protecting for concrete. Okay, let's move on. Yes. Wood. Wood is historical product and of course it's future product, like you know. And of course, always or one option is protect wood against fire is impregnation. But if the wood is already treated with some another product, what we can do? Because like we know that it's not possible to do this work with impregnation, because you can do it. For this, we have a very good range again from Amon. They call it Amotherm wood range, and they have especially good solutions for new wood. And of course, especially if you have already coated or painted wood, then you can use Amotherm products on it without problems. Because they have solutions. They have solutions if you need transparent product. They have solutions if you need colored products. With low VOC water-based products they can offer, and also they have if you need more resistant, they have also polyurethane products, and especially they have also floor product products for floors and stairs, and this is like luck, a little tintable. All the products is possible to get different how to say shades or yeah, and maybe what is interesting for this flooring floors and stairs products, that also they have these products is approved by professional basketball teams. Then it's mean, or it proves that these products is probably strong enough to protect your floors. Yeah, then this is option what we can offer to solve your fire protection for wood needs, and if you need additional information, then you are free to contact with our technical team. Okay, time is going. Let's move on. Okay, finally, I just give a short overview about a little penetration business that Forum have made a couple new nice updates for the market. Again, like you see that this popular wood and timber area is also in Forum mind, and now they have good solutions for cross-laminated timber walls and floors with FR board, graphite, and acrylic. Maybe interesting and important to know that now they have solutions for insulated plastic pipes in rigid floors. Also, more and more popular is quick and simple installing putty board, putty solutions for pipe installers and so on. And the last couple updates are that they came out with a waterproofer for gypsum mortars to get extra waterproof for the gypsum, and it's even possible to use with the competitors' mortars. Also, it looks like Forum is ready to enter now to the steel business. They have came out with intumescent paint for steel. At the moment, we don't have ETA for our market, but when we will get it, then we will share it with our customers as soon as possible. Okay, then let's move on. Also, as distributor of FSI Limited, we have a couple good news from FSI side as well. Like finally, they have new updates for pyroacoustic sealant. Also, it's very important and glad to say that they have putting a lot of energy and making good new tests for cavity barrier range, and now they have good range for ventilated and non-ventilated facades. Then, silicon is updated. Also, Benopatch product. This is similar like putty product, and also now they have in the range 2-component foam. And finally, our old partner FireSafe, they have came out with new KPG mortar installation bricks. What are like small bricks, what saving installers time a lot, because with those bricks it's possible to just build up big holes, and later just you can seal it with liquid KPG mortar. Then who is anyway fire safe products user, then I need to tell that they have also a new update for fire safe graphite. And also now they have making, we can say, new option for fire safe cable reserve, what based mainly on ETA of KPG. Yeah, it was a very quick overview about the last updates and maybe the main or the couple interesting products what we wanted to present for you. What was solutions for concrete and wood. But of course, like you said, that like you see that we have a lot of different options for you. Then it's generally it's all today from my side. Yes, and finally, I want to say that, like I explained, that our markets are very difficult and different. We need to follow the needs of our customers. That's why we are holding in our toolbox many different brands and partners. I want to say that Kenoke Trading is we don't have competitors, we have only partners. Then we are ready and are waiting to working always together with everybody. Our technical team are waiting your requests and we are glad to help you. And yeah, finally, I want to say that we don't offer only brands alone. We want to offer for our customers full solutions. Thank you for your time. Stay safe and have a nice day. Bye.
Good afternoon. Now, I'd say I'm very delighted to see you all after lunch. And we shall talk about very, very, very common problem, which is almost in every high-rise apartment. So the crowded parkings. Lots of spaces which are already busy with kid activities, trees, grandma's flowers, and so on, which make difficulties for fire engines, of our vessels, the automatic ladders to come and start extinguishing measures or evacuation procedures of the people who are in a building which is on fire. So our also next topic will be quite about that. But almost every fire designer knows that this is the same thing. They are obliged to design that. But does everyone understand the cause of that? Why do they do that?
Yes, no, they
Yes
don't
and no.
understand. Yes,
true.
they don't understand that, and it is very, very important is to reach for firefighters this place. And as you have mentioned about some tasks is the one tasks and the huge task is to reach.
Yes.
It's roads or ways is so crowded by the parked cars. That is difficult to reach this place of the building. And also, if you reach this place, it's very difficult to place especially ladders to reach the highest part of the building to make some rescue procedures and so on and so on. So it's a very difficult way. And okay, when we build a building in the start, it's okay.
Yeah,
it's designed, it's already prepared. But after time, after 5 years, 10 years, it's growing the trees, it's kid activities, other activities, some parking measures to avoid some cars.
It's a bit of a ticking bomb, I'd say.
Yeah. And we had some cases in Vilnius and in other places.
Yeah.
And
sad stories.
Yeah, sad stories. and yeah, it's
Well, Vilnius municipality took one step ahead. They showed the beautiful road sign that there is some area, one line where no one can park the cars. But no one has ever obliged to this rule. What should we do? Is it again bureaucratic, question? Should police
and
take?
we have legislation also in the law that that firefighters could damage some cars or so to reach these buildings.
Okay.
But
so you state that this is the same like in the US. If we have to break the window, we can. I mean the firefighters.
Yes, but the most important, why this car and why this place?
Okay. Because then it's a lawsuit.
So the additional signs,
exactly.
like in the Vilnius municipality,
yes,
it's signed some place where is dedicated for fire safety.
Exactly. Yeah. It's also, I think, the yellow line.
Showing
that. Okay, there's a good start after lunch, and we are now connecting with Kielce in Poland, and we are waiting for Piotr Witon, who is a representative of CMF Plus company. He's a fire safety expert, and he will have a presentation right about this topic. So, Piotr, the stage is yours.
Good morning to you. Thank you for the invitation. My name is Piotr Witon, and I will have the pleasure to present you with a lecture on important recommendations related to design of fire routes. The lecture will also be addressed to firefighters who use fire routes during rescue and firefighting operations. The content of the lecture is based on my own experience while working as a firefighter officer in Poland and also as a fire safety expert, while cooperating with architects in the design of buildings that require a fire route. Fire routes are intended for firefighting vehicles as well as ladders or lift truck. While a poorly designed fire route will not significantly affect the possibility of using and extinguishing vehicles, in case of a mechanical ladder, it may make it impossible to use it and sometimes even lead to its overturning. It is also important for firefighters themselves to know which working conditions for a mechanical ladder will be optimal and which may endanger their safety. Sometimes the operator of a mechanical ladder takes a conscious risk, for example, bearing in mind the need to save endangered human lives. During the preparation of the materials for this presentation, I analyzed the available regulations from several European countries on the requirements for fire routes. In the following, I presented those of them which I found the most interesting. What regulations should a fire route meet in Poland? I will briefly outline it. The route must be between 3.5 and 4 meters wide. It must end with 20 meter by 20 meter maneuvering area, or have another solution allowing the vehicle to turn around without reversing. There are allowed sections from which reversing is possible, but not longer than 15 meters. The road must be able to withstand a vehicle axle load of 100 kilonewtons, and its longitudinal gradient must not exceed 5%. The outer radius of the curve of the road shall not be less than 11 meters. The road must be at a distance of between 5 and 15 meters from public buildings, and between 5 meters and 25 meters from industrial and storage buildings. The road should be connected to the entrance to the building by an access passage with a minimum width of 1.5 meter and a maximum length of 50 meters. The road must run along the longer side of the building, and its width is greater than 60 meters, and then on both sides. These requirements are very similar to those of other European countries. It is worth considering which of them are justified from the point of view of firefighting operations and which should be changed. One of the specified parameters of the fire route is its maximum longitudinal slope. In various countries, it ranges from 5% to 10%. And now a question, what slope does the ladder manufacturer allow? We check it on our vehicle. Modern ladders allow work with an inclination angle of up to 10 degrees, which is equivalent to an inclination of about 17%. Of course, it should be remembered that in case of a high slope of the road, an unfavorable wind, the ladder can automatically limit its range of operation. Equally important is the surface of the fire route on which this slope occurs. In the picture shown, even if the slope of the fire route is kept at 5%, the operation of a mechanical ladder could be dangerous. Another important parameter of the fire route will be the minimum turning radius. It is particularly important for longer vehicles, for example, a mechanical ladder. In Poland, the smallest radius of the external curve of the fire route cannot be less than 11 meters, with minimum width of the road 4 meters. For example, in Spain, the smallest radius of the external curve of the fire route must be at least 12.5 meters, with minimum width 7.2 meters. To answer the question of which road width and minimum radius of its curve is correct, we have done a test for 2 types of vehicles. It should be highlighted that the contour diameter of the turning circle of the vehicle was measured. As a result of experience, it was found that the road width of 4 meters and its radius of 11 meters are sufficient for short bends, whereas when the angle exceeds 40 to 50 degrees, the wheels of the vehicle start to move out of the designated border road line. Maybe the German model might be the best solution when designing fire routes. It makes the turning radius of the road dependent on its width in this section. It also requires its smooth widening in the section of road approaching the turn. For example, a 3 meters wide road is required for a curve with a radius of more than 70 meters, while a 5 meter wide road is required for a radius of 11 meters. It should be remembered that even when a fire route is designed in accordance with the provision, but the provision is met in a minimal way and other aspects are not generally taken into account, these fire routes may not fulfill their rule. As can be seen in the pictures, the passage of the mechanical ladder is in such conditions, despite their compliance with the regulations, may be difficult. Other solutions worth highlighting, taken from European countries' legislation, is that, for example, in Germany, obstacles along the fire route, for example, speed bumps, must not be higher than 8 centimeters and at least 10 meters apart. Another from Germany is that at a distance of up to 8 meters in front of and behind the crossings, all-terrain slopes are inadmissible. Also in German, walls and ceilings of communication routes, passages, must be fireproof. For example, in Spain, the maximum allowable slope of the route, of the fire route, is 10%. And in Lithuania, roads and squares must always be free, marked and secured with fences up to 20 centimeters high. Another important thing is the proper design of the fire route right next to the building, and in particular its width and distance from the building. In order to be able to use a ladder vehicle safely, using all the available parameters, it is necessary to provide the right conditions for, among other things, setting up its hydraulic supports. The supports must be laid out on firm and flat ground, must not rest on manholes, and should not be used on soft ground. Also, obstacles located within the road border or, for example, parking cars may disable the full extension of the hydraulic supports. The key parameter of each mechanical ladder is its range of working area. As can be seen in the diagram for ladder SD37, where 37 means the maximum rescue height calculated in meters, the rescue height of the ladder depends on its distance from the building and the load of the rescue basket. The length of extension of hydraulic supports is also very important. The minimum width of the hydraulic supports extension is 2 and 6 meters, and the maximum is 5 and 2 meters. For the minimum extension of the supports, the range of the working area of the ladder can be reduced by up to 50%. As can be seen in the diagram, the maximum rescue height for this ladder is reached at the distance of 5 meters from the building. Neither further nor closer. For the evacuation of 2 people together with 1 firefighter in a basket, the maximum available distance from the building will be about only 40 meters. Let's see what the regulations in each country say on this subject. For example, in Poland, the distance from the fire route to the public building should be between 5 and 15 meters. The distance from the fire route to the warehouse building should be between 5 and 25 meters. The width of the fire route next to the building is 4 meters, regardless of its height and purpose. For example, in Spain, the road next to buildings over 9 meters should be at least 5 meters wide. The maximum distance of the fire route from the building is for buildings up to a height of 15 meters, up to 23 meters. Buildings between 15 and 20 meters up to 18 meters, and buildings over 20 meters up to 10 meters. The German standard also makes the distance of the fire route from the building depends on its height. For buildings between 8 and 18 meters high, this distance must be between 3 and 9 meters, while for buildings over 18 meters high, this distance is between 3 and 6 meters. The German standards also includes the obligation to leave a 2 meters strip of free space on the opposite side of the road to the building. This is a great importance from the point of view of free maneuvering of the ladder's arm, because when it rotates, the back side of the ladder extends beyond the outline of the vehicle. In the picture below, you can see how the fire route along the border of the fence or wall can make it difficult to operate the ladder's arm. Most provisions also point to the obligation to provide free space between the fire route and the building. In Poland, for example, between a fire route and the wall of the building, there must be no fixed land use elements or trees and bushes more than 3 meters high, preventing access to the facade of the building by means of lifts, track, and mechanical ladders. This obligation should also apply to the space above the road. As you can see in the picture, in particular tree crowns or power or tram lines. When determining the conditions of access to the building for rescue teams, it should also be taken into account whether the evacuation of people can be carried out through external windows of the building, and if so, whether such windows have been adapted for this purpose. The action consisting in extending the ladder basket right by the window will not require special window construction. On the other hand, backing the ladder basket in the window will require its special construction and dimensions. Lining the ladder basket against the window structure gives the possibility to create the so-called bridge, thanks to which it is possible to evacuate more people in a shorter time than in the case of the necessity to bring people in the basket to the ground. The optimal connection of the fire route to the building will also provide the possibility of evacuation of people, for example, from the roof of the building, or special zones designed to wait for people to be rescued. Current regulation in Poland allow evacuation of people outside the building or saving them in another ways, for example, by providing so-called survival zones. Providing free access to the building through the ladder basket also gives the possibility to evacuate disabled people in wheelchairs. All these activities require a very precise access of the mechanical ladder to the building. Another important parameter of the fire route is its load capacity. Most of MIT standards set minimum requirements for the axle load of a vehicle on the road. In Polish regulations, it cannot be greater than 100 kilonewtons. These provisions also result from general resistance requirements for public roads, and in most cases they are easily to meet. The problem, which is not often seen in standards, is the routing of the fire route along the ceiling of the building, for example, above the underground garage. The standards specify the parameters of the ceiling on which the fire route is routed, only because of the movement of fire vehicles. Why they don't indicate any restriction, for example, in relation to the use of a mechanical ladder. During its use, the hydraulic supports are extended and the whole weight of the vehicle is supported on them. The question arises whether building architects take into account the possibility of point puncture of the ceiling by the vehicle support. Another question is whether the driver of a firefighting vehicle is aware that the vehicle is now located on the ceiling of the underground part of the building. For a mechanical ladder, the load transferred to the ceiling from the vehicle supports is about 120 Newton per centimeters square. It can be lowered by using special sleepers placed under the vehicle supports. What is important, in case of the ladder, part of the vehicle weight is also carried by the vehicle's wheels. But while in the case of a lift truck, the entire weight of the vehicle rests only on 4 supports of 22 centimeters each. In this case, both the building designer and the driver of the vehicle should be aware of danger of using such a vehicle is on the building ceiling. The last parameter of the fire route I wanted to discuss is its ending with a maneuvering area. A lot of European standards dictate that the fire route should be terminated in a way that ensures that there is no need to reverse the vehicle. A lot of cases say that it is necessary to provide a maneuvering area of 20 meters by 20 meters. The question arises whether a yard of such dimension guarantees that there is no need to reverse the vehicle. An additional aspect is the question whether such a square will also be available and will not serve as an informal parking lot for resistance vehicles. The Irish standard indicates the minimum turning back diameters between curbs and between walls, taking into account, of course, the contouring diameter of turning vehicles. Additionally, it differentiates the type of vehicles that will use the fire route, combining this directly with the height of the building. For example, buildings up to 11 meters high and those above. We have a film now. In order to answer the question whether a 20 meters by 20 meters maneuvering area will be sufficient for turning the vehicle back without reversing, we conducted a test with both firefighting vehicles and ladder vehicles. As you can see, free turning was not possible on a square of such dimension. Of course, one may wonder about the different location of the entrance to the square, but since the regulation don't regulate this issue in such detail, this was not taken into account. It should also be taken into account that such a square may give the possibility to turn back 2, maximum 3 vehicles. The rest of them blocking the exit road from the maneuvering area will have to reverse the vehicle in order to allow the exit from the square. The question is whether maneuvering yards with such a large surface area fulfill their rule. We try to determine a different shape of a maneuvering yard based on the letter T. This yard is much smaller than a square yard, but of course it allows only one vehicle to turn back. On the basis of tests for various vehicles, we were able to determine the shape of the square to guarantee safe turning back of the fire vehicle. Of course, this drawing is illustrative and cannot be treated as an official guideline for the design of fire route due to the fact that in some countries there are precise guidelines on how the turning back site should look like. The following, for example, the following sketch from the England standards shows an example of a T solution. This diagram defines the maximum distance after which the vehicle can reverse. It is 20 meters. And the drawing doesn't indicate other road parameters. In some cases, it is worth considering whether placing a maneuvering area in front of the building would not be a better solution than placing it behind the building. Of course, what is the benefits of placing that way? Firstly, it will be turning back of all vehicles. The second one, using the maneuvering area during operations, for example, by maneuvering water supply vehicles. The next one is the possibility of organizing a reception point for forces and measures. And the other is space to maneuver other services, for example, ambulances, police, or other. And the last one is no traffic collisions with private vehicles parked on the maneuvering area. Of course, the current regulations don't allow such a situation. But in my opinion, it is worth remembering about this solution as an additional one. The last topic I wanted to just signal was the knowledge of the firefighters about the fire equipment used in the building. Does a firefighter who arrived to the building by fire route know what kind of devices it is equipped with? In my opinion, it is worth remembering about marking the staircase from the side of the fire route. For example, information about the type of installation protecting the stairs in the building against smoke. For example, if there is a pressure differential system or smoke extraction system with mechanical air supply, or just a gravitational smoke extraction system. Sometimes a simple drawing can direct the rescue tactics for the action commander and can prevent making mistakes. It seems to me that it is worthwhile to raise this topic at another meeting. In the end, I want to briefly summarize my speech, quoting its main conclusions. The width of the fire route must be adjusted to local conditions. Fences, field obstacles, purpose of development, for example, housing estates. The best way to get the fire route is to go around the building. The fire route running along the curve is wider in this section. The fire route leading on the ceiling is clearly marked and place to operate the mechanical ladder are designated because of the puncture-resistant local ceiling, for example. The distance of the fire route from the protected building depends on its height. For example, from 5 to 10 meters for buildings over 20 meters high, for example. On the external side of the fire route by the building, a 2 meters free space is provided. The fire route has maneuvering points that can provide space for optimal positioning of the mechanical ladder and vehicle overturning. Windows intended for rescue teams have an appropriate point of attachment of the ladder basket, load capacity and width. A good solution would be to use a balcony ceiling or flat roof of the building, possibly to evacuate people or save them in another way. You can also evacuate of disabled people. If it is not possible to provide adequate access for mechanical ladders, replacement solution should be based on improving the conditions for evacuation from the building by means of general communication and using non-flammable building materials for the roof and facade of the building. Thank you very much for your attention, and I also thank the organizers of the Baltic Fire Forum for inviting me to participate in this great conference. I hope that my presentation will help you to take a different look at the issue of bringing fire routes to a building from both the sides of the building's designer and its use by the fire service. If you have any questions or suggestions, please don't hesitate to contact me by an email. Thank you very much. Bye.
So Piotr, thank you very much. Very interesting case. Also, thank you very much for those video moments, which really describe us why it is so much important. Because sometimes when you see just the pictures and on the fire code, and you see, okay, it has to be like 16 meters on 16 meters, or 20 on 20. There's one thing, but when you see a problem for fire engine to make a round. So this just gives you a whole idea why those things are so much important, because in saving people's lives, the most important thing is time. So here we can have it. Okay, our next presenter, Dorothy Y, is representing Hilti and the fire stopping squad. This is really, from my point of view, very interesting topic, because all the active fire safety systems are having always this problem that they sometimes there may be a moment that they will not work.
Yes.
Do you agree with that?
Yes, I agree.
What will save you then? Only with passive fire safety systems. So good walls, fire-rated doors. Yes, these are really essential things. I do not always agree with some construction experts saying that, well, we can do this the same with a cement, or just bricks, and this is it. This is okay. And this is not right. We have to use professional, tested, certified intumescent systems, and I'm very glad that Hilti is showing actually the leadership in giving us so much and so variable amount of tests for fire stopping systems, which are, tremendous fire resistances, up to 3 hours, sometimes up to 4 hours. And, wow, this is really great. But the most important things sometimes now in construction is the variability, where you can use this. Yeah. And is it certified? Does it have the documents or not? Because believe it or not, but in the end of the day, all the fire inspectors are checking the papers.
But I hope that all the engineers and the installers doing that, not for the inspectors, but it's for the fire.
Yeah.
In the case of the fire, to reduce the damages and also the people losses. So it's
Yeah, you're totally right. I guess to this. So the stage is yours. It's Dorothy Y. Hilty. Thank you very much.
Hi everyone, welcome to the Baltic's Fire Safety Technology Forum, and thank you for joining me today. My name is Dorothy White, Fire Protection Product Manager of Hilti Corporation. So let me start with a brief introduction of my company. Hilti is a family-owned company founded in Liechtenstein with 79 years experience in manufacturing construction materials. Today, we have our international teams made of technical, sales, and customer service, and we are present in over 120 countries. And fire protection is always one of the focus business in Hilti. We have continuously invested in fire protection, research, development, and testing for over 25 years. Today, I want to share with you some real-life challenges that designers and contractors face when it comes to designing and installing a compliant fire stop system and the solution to it. So let's start with the why and what. Why fire stop and what is fire stop? Then we can discuss what is an approved fire stop system and what designers should know when designing a fire stop system that fits the application need. Let's start by watching a video to understand the why.
Typically, 5 minutes is all you get. Fire, and especially smoke, spread through a building much faster than most people think. Every year, about 3.8 million fires occur worldwide. While damage to assets is in the billions, the yearly death toll amounts to 45,000 persons. Much of this could have been prevented if correctly installed fire protection had been in place.
Architects, planners, engineers, and building owners are responsible for effective fire protection. Oftentimes, they do not realize that fire stop is not an option. It's a clear legal requirement, and negligence or improper execution is a violation of the law. Nearly 60% of fire deaths are not in the room of the fire's origin, and 3/4 of all fire deaths are caused by smoke. When there are through penetrations in walls and floors, toxic smoke easily spreads to adjacent rooms. The keys to effective fire protection are both active protection, such as detectors and sprinklers, but also passive protection. Passive means that penetrations in walls and floors have been sealed with approved fire stop products. This principle is called compartmentation. When installed correctly, fire and smoke won't be able to spread from one compartment to another. This allows for safe evacuation of people and protects valuable assets. The thing about compartmentation and fire protection is it's only as good as the products you use. You know, one always thinks that accidents only happen to other people. That's a false conclusion. It is the responsibility of architects, planners, engineers, and building owners to protect lives and assets by effective and well-designed compartmentation. Hilti offers innovative and legally compliant, internationally approved solutions. We recommend Hilti to be on the safe side.
So as you can see in the video, we learned that the leading killer in fire is actually smoke and the toxic gases. And how important is it to contain them? So statistics tell us there's 3/4 of that are caused by smoke. And more than half of the time, that doesn't happen in the room of the fire's origin. In a fire situation, half of the people are not able to see clearly and find the escape route because they can't see more than 3.5 meters. That is because of low visibility. And the low visibility is caused by smoke because smoke travels at a speed of 0.6 to 2.2 meters per second. And if you are a young, healthy person and realize the fire in time, you might be able to outrun the smoke. But what if you are an elderly, child, or even a patient with limited mobility in a hospital? They stand a very low chance to escape when smoke can actually fill up a room in less than 2 minutes. So what are the measures that we can take in case of fire? We have detection system to detect fire and also activate the suppression systems like the sprinkler, as well as trigger a call to the rescue team to the firefighter. And at the same time, containing the fire in its origin allow time for the firefighter to come so that people can escape. And that is why we need to have a balanced approach to fire protection. That means these three systems should always be in place to bring the risk of fire spread down to minimum. And in order to contain the fire from its origins, it happens in a very early on in a design phase of a project. So it is a universal rules that buildings are designed for with compartmentation, with the fire-rated wall and floors to contain the fire from spreading from its origin for a certain time. But these walls and floors, they always have building surfaces like the pipes, like the cables running fluid. And when these pipes and cable run fluid, it leaves an annular gap or openings. So it is very important that we adopt a fire stop system to restore the integrity of the wall or floor and resist the spread of smoke and fire from one room to another room. Now let's take a look of the fire stop system that we are talking about. So let me start with the codes and standards. Depending on the countries, the test standard for fire stop system is different. In Baltic states, the fire stop system with penetrants like pipes and cables are tested to the test standard EN 1366 Part 3, and a successful test will give us an approval document called European Technical Assessment in all the EU countries except Germany. And how do we get the approval document? First, we need to undergo a fire test. So for the fire test procedure, first we put the assembly in place on a furnace, and then we expose it to fire under a condition stated in the test standard. For example, 20 Pascal in oven pressure. And for the flue penetration, if flame and gases doesn't ignite the cotton pad, that means it passed the integrity rating. And if the temperature doesn't reach the temperature rise doesn't reach 180 at a single point and 140 Celsius degree for the average thermometer point, then you reach an integrity rating. You reach an installation rating that is stated in the approval document. And there are some key parameters that designers should pay attention in the approval document in order to be code compliant. The first one is about the setup. That includes the base material detail, whether it is a drywall, whether it is concrete wall, whether it is a wall or floor setting, and also how thick is the base material. For example, a thinner base material gives less resistance to fire than a thicker one. Opening sizes also matter. Make sure the maximum opening size is covered in your approval document. And the second parameter that one should pay attention is the penetrance. Take pipes as an example. The material of the pipe, the diameter of the pipe, and also the wall thickness of the pipe is very important, because a different wall thickness, different material of pipe, they behave very differently in fire. And also whether the pipe ends are both kept only on the fire side or non-fire side, this again will affect the fire performance. And the third parameter is the fire stopping materials. So for example, is the position of the products designed correctly? Is the amount of product used precisely? So let's take some traditional fire stop product like fire stop sealant, for example. when you have the bigger pipe or when you have a bigger annular gap between the wall and the pipe, the thicker the sealant you should apply. So you have to double check all these parameters to decide if the fire stop product that you choose will form an effective fire stop system. So a very quick question is, after you learn all the parameters, now you know that when someone tells you a fire stopping product can give you a fire rating of, let's say, EI 120, integrity installation 120 minutes, is an incorrect statement, because a fire stop product itself, a fire stop product performs differently with different base material, different pipes. So we should always check if these parameters of the real life application are well covered by the product's approval document. And what happened in the real life application? So sometimes, even when there's perfect design, error could happen during the execution or installation phase, especially when the work itself is very labor intensive. We often hear our engineers, we always hear from consultant or inspector that traditional fire stop systems are installed incorrectly. So on the left-hand side, you can see in the photo that fire stop sealant was used, fire stop collar was also used. But the problem is that the opening is bigger than the collar that has tested. And more often, when the opening size, if the opening size is all right, the worker might apply the wrong volume of sealant. They are very common error in real life situation. And what it means to inspector, that means for them, they will have to remove the sealant. They will have to conduct a destructive test to determine if the right amount of sealant is used. And there's a second case when we have some renovation project. And if it's not coordinated well during the updates of pipes, we might sometimes forget to seal up the opening again, and the opening might be left open and it poses a very big fire risk. So to reduce the human error during the installation of fire stop products, a lot of countries like in the United States or even from in the United Kingdom, they start adopting casting device. It is a fire stopping device that has built-in fire stop rack in it, and it is cast before the concrete is poured. So in this way, the human error is minimized because it is built in and it is preformed, and you don't need to worry about the depth of sealant. There's no need for a destructive test as well. And if you can see my screen here, this is the product that our company also has. And as you can see, or we have a intumescent wrap already built in the device. And there's also other reason that why it is becoming a more common method. That is because of the productivity gain with this method. So you can see on the left-hand side is a step in a traditional method to create opening and fire stop. So you first lay your rebar, and then you have the contractor go to the job site, build the formwork to create the opening. You then pour the concrete, you run the pipe, and after the concrete is cured, you have to even come back to fire stop it. And then for the casting method, you simply position your fire stop device at the same time, and also you simply position your fire stop device in the job site. At the same time, you create the opening and also have the fire stop, preformed fire stop inside it. And then you lay the rebar, you wait until the concrete is poured, and then your job is done, because you don't have to come back to do the fire stop work. So there is actually a significantly speed up in terms of the installation, and you also remove the most labor intensive part in the workflow. That means having a labor and come back to fire stop the opening. And then we always compared it as a traditional method versus a modern method. So depending on your need. And the bottom line is the fire stop solution that you pick should always fit your application need. If the project needs is only the minimum traditional fire stop system that is code compliance, then the traditional fire stop system will work. But if your need is to ensure that you have a correct installation and have an easy inspection, and also if you want to increase your installation speed, reduce the labor costs, if that is the goal of your project, then Preform fire stop system can support you. And if you are an architect, MEP consultant, or inspector who frequently deal with fire stop decision, Hilti has also developed design software and inspection tools to support your fire stop design. Thank you. Thanks a lot for joining me today. If you have any questions regarding fire stopping system design and software, feel free to reach out to my colleagues who are based in Lithuania and Baltic region, Donatas and Nikita, and myself. Thank you.
Thank you very much, Dorothy. That's what I've expected. Really good presentation. Thank you very much. Fire stopping rules. This is also my activities. That's why I'm also voting for Hilti and Dorothy herself. The next topic is opposite. This is active fire safety systems. And we shall talk about high efficiency foams. High efficiency foams. Can you tell me what it is? Because I totally forgot my university studies with foams and so on.
Very sad in this age. So high expansion foam is quite popular when we're extinguishing some volumes, fire and volume, and in the big apartments, hangars, and some places where you have to extinguish all the room in one time. So
basically, it's kind of
by foam,
Kubaturic fire extinguishing.
The most expanded volume is lightest, expanded the most.
Okay.
And
so if we talk about plane hangers, this is it. This is the thing.
Yeah. We fill with the foam all the room, and in this case we have extinguisher that. And
we have highly effective foam which organizes all those limitations of flammability and flame propagation. I do understand.
It's extinguishing. You isolate from the oxygen, from the material from the oxygen is the main task of that, and also to reduce the temperature.
Sure.
Okay. So it's the main task.
Let's just not forget the burning triangle. The university.
But I
lectures.
hope that the companies who are using that know a little bit more than we.
Sure. That's why I would like to present you Kamil Marianek from company Fomax, and he will explain and talk a bit more and more efficiently than we're trying to do that here. Kamil, the stage is yours.
Hello again, Kamil Marianek. Okay, so let's go to the next topic. The protection of warehouses, especially where we cannot fulfill the NFPA 13, as clients would like to have bigger drums than 65 liters when the temperature is less than 93 degrees, as they would like to have the tank drums or IBC containers even in a plastic, but according to NFPA 13 within a sprinklers 65, it's the biggest one, it's in metal. So let's go and speak about it. Oh, I have to change it in the other way, the slide. One moment, please. Okie dokie. It should work now. Yes. We see how on the slides there are general information how properly high expansion foam works. So the cutting combustible material from the fire, cooling the system. We have to remember that when you are having a high expansion foam system, it's cooling all the warehouse or the fire area, as we are completely filling by foam all the area. Eliminating the oxidant impact on the chemical reactions to stop. These are basically 4 points how properly should work high expansion foam system. And simulation of the fire. We can see that we just did it with our client. It was Eurofoam company. It's Austrian company. They are producing foam which you are using in cars. They are making beds from it. So there are many types of potential usage. And we just had the warehouse where they store the foam. It was up to 8 meters, and we just make a simulation of fire. How it will work when we would just catch fire on the ground. And after 70 seconds, the smoke detectors start. So it means that if smoke detectors after 70 seconds started, it means that after 10 or 15 minutes, our high expansion system will start working. But okay, it was simulation for the sprinkler. The first sprinkler opened at 175 seconds. The first smoke flap opened in 178 seconds. And look, just only within 16 seconds from the first open head of sprinkler, the fire went to uncontrolled phase. 16 seconds only from the open first head to the uncontrolled phase. So that's why, and this simulation was done when we used ESFR K360, so the biggest sprinkler which is now on the market. And look what happens. If it will be foam system, 70 seconds detectors start. If we will have better detectors, suction detectors, it can be even 30 seconds, 40 seconds, and after 10-15 seconds, we will have a foam. Look what is happening with the sprinklers. We can be 100% sure that they will never prevent, especially with the foam plastic. That's why we spoke with this client over 3 years. This client also has a fire in the other plant, and the warehouse was completely destroyed. There was a lot of foam inside, but they had sprinklers, and it wasn't good. It wasn't good for client. The warehouse was completely destroyed, so the plant was stopped. Massive costs. That's why they decide to search for other solution for the other warehouses, and they contact us. We spoke with them over 2 years when we proposed them several simulations, several solutions. At the end, they used the highest quality system, Ansel. It's American system, everything produced in US. Ansel high expansion foam system, which has UL and FM approval. About the high expansion, I think that everyone knows that it need to has the expansion ratio not less than 200. Normally it's 600, but with our generators it can be really close to 1000 expansion ratio. The systems we can also divide for the system which are using fresh air from outside the building, and these are always the FM systems. And there are also systems from insider, like our hot foam, when we prove that's working within a temperature 1000 degrees. Later I will show you the movie with the tests. how exactly this foam acts now, and in this scenario, and why client decide this expanded foam produced by client really fastly, because it's a high, I don't know, 8 meters by 30 meters length. It's like a warehouse in warehouse. We just within less than 2 minutes, we just protect all surface of this expanded foam. We just protect it in case of contact with oxygen. So it means that if there is no oxygen contact within a plastic, there is no fire. So within less than 2 minutes, we just prevent it to expand this fire to really big scenario. The heat from the fire is crazy. We just check in simulation that when it starts, as you just saw, just only 16 seconds from opening first sprinkler head, fire went down to the uncontrolled. So amount of heat is crazy. We see that advantages of high-X. What are other advantages? We are not using a lot of water, so it means that if you will compare our system and it's working 3-4 minutes only within a sprinkler system. Within a sprinkler system, just showing that the damage done by water with our system are much smaller than it is with water sprinkler. Also, wetting by our foam agent is much lower. Wetting, of course, of the products which are inside. It's much lower within a foam solution than it's with the water, when from ASFR sprinkler can go even 500 liters or even more, 800 liters per minute, depends on the pressure, to one place. So the damages of the wetting will be much higher than they are from the foam. So we can see here now where you can use the high expansion in basements, cable tunnels, mines, aircrafts, hangars, warehouses, closed spaces, power plants too. We can see usage, so how we can high expansion foam protect the spill fire, and how we can protect 3-dimensional hazard by this. Okay, let's just start this movie. The first thing, what is really important from this movie, it's that always we have to blame a firefighters because of the fire. Always we're at the movie in the test, there's one firefighter catching a fire, always. Okay, about the details. It was the tests with our hot foam system, so it means that it used inside air. How we prove that's working? There was 2 plates, as you can see, 2 plates with a heptane hexane. We just add acids, several acids, to just create the worst substance as possible, as all the acids are also destroying a lot of the foam, and that's why we'd like to check it. We've been waiting when the temperature on the roof, where are the generators, will be higher than 1000 degrees. To have it this, as we can see, there is a ventilator. There is a vent, as we can see on the ground, because when we just make it without this fan, the amount of oxygen inside was too low. That's why we didn't get 1000 degrees. So to have it 1000 degrees, we need air from outside. As you can see now, the flames are going below the roof. Look at closely. And how we start action? We've been waiting for our 2 thermal capsules. When they are destroyed, action will start. We see that it's a really inside there, because flames are close to the roof. It's a place where we just mounted generators. And what is also very important, you will see when the action will start, that the generators wasn't exactly above the fire. And you can see there. Here's a moment when the two thermal capsules opened. You can see at the very first moment that it will reduce the flames. The smoke will go down. Yeah, now it's not yet activated. Down. Activation of the system. Look what is happening. Immediately, we didn't see the flames. So the temperature went down a lot. So the roof, it's also much better protected than it was without it. Okay, because the fan is working, we can see on the ground. We can see on the ground what is happening. There is a massive fire, and within a moment we will start see the foam on the floor. Oh no. Fan is good and bad because fan is also mechanically destroying the foam, which is inside, as we can see. So it was also the consumption of the foam, because not only by the fire, it was also by the vent. And all the calculations we just did according to NFPA 11. So it doesn't matter if this warehouse is having space like here, 600 cubic meters, or it's higher. We use same formula to calculate it. So it doesn't matter how big will be, how much bigger will be your warehouse. Same idea and same formula will be used. So the amount of foam agent per square meters will be same. And we see that the bottom layer is already extinguished. Now the foam is fighting with the top level. Of course, if you would like to have it detailed information and test report results from us, just send me mail. I can share with you all the informations. And you can see here is we see that it's almost finished, just few more meters of foam and it will be extinguished. But we see that the fire now, it's not so crazy. Or we see that fire was extinguished when the vent, this blanket, they put it higher and the vent didn't destroy the foam. So it is extinguishment. So in the test report, you can see the test results, and we are what we claim before, and by what parameters we just did our calculation. We just prove it with the smoke. Okay. Let's go to the picture. In this picture, you can see how it looks like exactly. It was 3 plates with 3 different types of flammable liquids with added acids and many others. In test result, as I just said, I can send you all the details of these liquids. And you can see it also at the top. Can we once again look closer? Okay. On the top, you can see small pipes, and you see the black, completely black, our generators. Look that they've been heated over 1000 degrees, as we just have in the result of the tests. And they're above 1000 degrees, but they still, when we start the action, work. So we just proved that using inside air, really with a lot of smoke, with a high temperature, 1000 degrees, we started 1000 degrees. We just proved that this system is working. This is the only one system on the world having in approval that it's a inside air system according to NFPA. So we can use or inside or outside air system. Both of them are approved by third parties. Okay, here you see how exactly this test look. We see that it was 8 foam generators. You see the plates inside. It was 4.5 meter, 2 meters. As you see, the foam was going out from generators to the left and right wall. So it means that it wasn't directly above the fire. It grew from the bottom and put a layer above the fire. So it wasn't easy to extinguish, for sure. Okay, here is a 3-dimensional fires design criteria. First, the toxicity of high expansion foam. Look, this is on this picture you can see me, and clients ask me many times what will happen if the action was started, and some people will be still inside. First, we are calculating according to an FPA that delay can be 30 seconds for the evacuation, and even if it will be installation will start, we are having a lot of approvals in which you can see that the biodegradability is more than 99% within 20 days. But everyone asks, okay, what will happen with the skin and with hands if you will touch this foam edge? I just prove it myself, and I check it myself that this what states all the approval there. It's not dangerous. It's not dangerous foam from our foam agent. It's true. I'm still having, look, nice face still. And there was no problem. Okay, let's just skip it because toxicity, believe me, you shouldn't afraid. This is the first thing which you will always start speaking with the client about the high expansion toxicity, what we will make with this foam, etc., etc. It's, believe me, that soap, it having toxicity, same as soap in your home. Okay, how we are properly designing. So let's just, I will just speak first how we should make it, and then we'll make a case study. We'll make a case study. Normally, we are just asking you for our parameters, and we are just putting to our calculator, and with a few seconds, you can see the test result, the result of the calculation. But to let you know how exactly it's working, let's just do it once this calculation ourselves without the calculator. Okay, so the R, it's a minimum rate of discharge of the foam agent. It's a cubic meters per minute. F, it's a minimum submergence volume. T, it's a time to achieve submergence. RS, rate of breakdown by sprinkler. CN, compensation of normal shrinkage. CL, compensation of normal leakage. Okay, submerge time. The time is based on few factors. First, what kind of hazards we are protecting. It's flammable liquids, I don't know, rubber, tires, many types of them we can protect. What is a building construction? And it's sprinklered or not sprinklered. And NFPA is giving us table in which we are having all these parameters. So let's look a bit closer. On the top, we are having the worst hazards. So it's a flammable liquids with enough flash point less than 38 degrees. And then we can see it's a light or unprotected steel construction. So if it's sprinklered, we are using 3 minutes extinguishing. If it's not sprinklered, we are using 2 minutes. And then heavy or protected for fire resistive construction. It's sprinkled, it's a 5 minutes, not sprinkled, it's a 3 minutes. And we can see that it's a combustible liquids above the 38, it's a low density, like a foam rubber from plastics, high density, roller paper or craft, high density combustibles, and rubber tires even, and combustible in carton bags or fiber drums. All the types we are having here in this table, and it's our parameter to formula. Okay, next one is rate of breakdown by sprinklers. If you are having a sprinklers, always sprinklers are, we can use it in case of protecting ceiling. We need to consider that when we are having foam installation, the sprinklers are just only supplementary protection. They are not main protection, they are just only supplementary. We can just have it sprinklers above the foam within a density from 10 to 40 millimeters per square minute per minute. It means 10 to 40 liters per minute per square meter only. It is only for ceiling protection. Sprinklers are here not extinguishing. They are just protecting ceiling if clients is having them or would like to have it together with a foam installation as it's required for him. So here we can see how we are calculating. So this breakdown in cubic meters per minute, shall be constant 0.0748. And here there is estimating discharge from the maximum number of the sprinklers expect to operate. So let's see that it will be 10 liters per minute with an over 250 meters, and it's 2000 liters per minute. And then we are just putting this in our formula, and we know how much more foam we needed from our foam system to avoid destroying them by a sprinkler. And here is a CL. It's this factor. It's we are just using normally 1.2 when we are not 100% sure that all the openings like doors, like windows, they are not having the automatic closing system. So we are not sure that that maybe our foam will go to the other area. So that's why we are putting 1.2. If we are sure, we can use it 1. But even if everything is protected and we think that the area is sealed, let's use it 1.2. Let's not go too often with a lower factor of CL. And complete flooding with the high X. What is important? So hazard classification, as we just spoke. Building construction, not sprinkler, sprinkler. Okie dokie. And submerged volume. We need to remember that we are not using, if it's a height of your racks, it's 6 meters. We are not calculating 6 meters to the volume of foam which we need. NFPA states that it always has to be 10% more than the highest storage height, but not less than 0.6 meter. So it means that if it will be 4 meters highest storage, we need to add 10% 4 by 4, but 4 by 4 is less than 4 by plus 0.6. So that's why, as a next factor, the height of foam volume, we are using 4.6. If it's above 6 meters, we are using 10%. If it will be 8 meters, we are using 8.8 because this 80 centimeters is more than the 60 centimeters. Let's skip it. But please look carefully now this picture. Just look this picture. The maximum height, it's not a height of approximately how the height look like. It's a height, if as here, if all the racks will be at 3 meters, but one will be at 5 meters, we need to use this 5 meters storage height. So that's why it's so important for client to have same level of all racks in the warehouse, to don't have, because of one rack, much bigger installation inside. Here it's duration time according. Let's just speak about the NFPA, because EN, in my opinion, is a copy of NFPA, but they just delayed few things, few important things, and they add themselves few points. And NFPA is much better to calculate high expression. I can say it. You can see here to just compare them, but believe me that NFPA it's most common used. And to be honest, I just did numbers of high expansion foam system, and even one wasn't done according to EN. All of them has been calculated according to NFPA 11. So it means here about the discharge duration that we normally we are having 25 minutes foam. We need foam for 25 minutes. So it means that we are calculating our foam tank and foam capacity for 25 minutes, but we can decrease it to the 15 minutes. If 15 minutes is enough to fill 4 times the hazard area. So simple. If the filling time is less than 3 minutes or less, 15 minutes will be okay. But if it's a 4 minutes, 4 minutes by 4 minutes is 16 minutes. 16 minutes is more than 15. That's why you need to use 25. But still, please do remember that all these results you are having from us, from our calculation system. It's on this slide. You can see exactly what I just said a moment ago. Okay, so let's go to the case study. So please take your notes. Please use length of 50 meters, width 25 meters, height 7 meters. And the storage height is 4.6 meters. What kind of storage materials you are having? There are liquids, a flash point above 38 minutes. Okay, no sprinklers, building construction according to NFPA. Okay, so let's make our calculation. So we see, we just need to now determine the required submergence volume. So the building floor area is 25 by 50. It's 1,250 square meters. Minimum fill depth in storage, as we just said, 1.1, but not less than 0.6. So as we can see, 4.6, 1 by 1, but not less than 0.6. It's a 5.2. We must fill to 5.2 meters. Okay, so the foam volume is 1,250 square meters times 5.2 meter of filling minimum storage. Determine required submergence time. As we just saw that it's a temperature above 38 degrees. There is no sprinkler, building type construction light. That's why, because of the above 38 degrees, we can use 3 minutes according to the table in an NFPA. Sorry. Once more. Okay, so here is our formula. So 6,500 meters SAV, T 3 minutes, RS 0 because there are no sprinklers, CN factor it's a 1.15, CL 1.2. And we see from this formula that we need per minute almost 3,000 cubic meters. So now we need to determine the number of the AG25 generators, discharge device required. So the required capacity is 2,180 cubic meter. Our generator capacity is 48 by 6. It's an inside air generator, 48 by 6 cubic meter per minute. And the number of generators we can see. That's a 62. So the system capacity will be 62 times 48 by 6.6. Okay. So now we need to determine the operation time and the amount of foam agent and amount of the water. So as we can see, run for 25 minutes, how it look like, filling time 4 times, run the system for 15 minutes, and as we can see that for 15 minutes, it's a 83,700, for 4 times it is only 48 liters, 48,000 liters per minute. So that's why we can go within a 15 minutes volume of foam agent. Okay, so now we need to calculate for a 2% how big our bladder tank has to be. So it's a 83,700 liters total consumption for a 15 minutes of water by 2% foam agent, because our hot foam is at 2% instead of other foam agents which are 3%. So for foam, high expansion foam, the best is 2%. And also you see that instead of 3,000 liters per minute, we can have it 2,000, not per minute. Instead of 3,000 liters bladder tank, we can have it 2,000 liters. So it's much smaller bladder tank and also much smaller foam agent. And including the 5 system overage imbalances, we see that it's a 1,925 liters bladder tank. So here is all the results. So we need how many number of, here is a mistake, sorry, it is 48.6, you shouldn't be here. It's on the boom, it's correct. 62 pieces of a G25. We need 2,000 liter bladder tank. We need a proportioner for a almost 5,500 liters. A water pump, 5,500, and the storage capacity of water has to be 82,000. Please check also always, because only water for 15 minutes. Please check how it looks like according to your local law. As in Poland, we need to have, even if it's a phone for 15 minutes, water tank always has to be for 2 hours. Okay, here you can see also the diagram P&ID, which we always, if you are on the stage where the clients has agreed our concept, and we are preparing for you as a designer or contractor company or firefighter, we are preparing for you full diagram with all requested detailed equipment, and it's shown always on the picture. So we are just doing for you. Okay, so here you can see the typical diagram how this system look like. It's a graphic version. So here's a water pump, here is a foam concentrate pump, alarm panel from the detectors, and then there is a pump and the proportioner system is activated, pump is start running. So at the end we are having on the generators, we are having a high expansion foam. Also, we just did a test according to APSAT T12 just to determine in case of the polar liquids, is our system working or not working. And we just determine that we just need to only add for 200 square meters, we just need to use the factor 1.85, but only for 200 meters. It means that if you're having area 1000, we are just adding few, like you can see here, 10 more generators for all area. It's nothing. It's nothing as for 1,500 square meters area, you need something like 150 generators. So our system is working also really well, not only with gasoline and other non-polar liquids, it's also working really well within a polar liquids. As our competition also did this test, Viking, we just check it how and where we are with our system, and you see that we are always on a green. Our competition is once yellow, second one is not red, pink maybe color. And if you will look at the last table where you are having, where they are using 6 bars, the foam agent, they need to have factor 17.38 instead of our 3.4. 6 times more they need. They claiming they are having nice and good ARC foam. Look the test result. Guys, do not believe data sheets. Look always test results. This is what you show you how good is your solution, or maybe how bad is your solution. Okie dokie. 2 types of generators, as we just said, insider and outsider. First, also they are aspirator type. It means they are because of this water mist going to the screen, they are, because of Venturi effect, they are sucking themselves and aspirating the foam on the screen of the generators, but they are having a bit lower expansion rate. It's like here is a 400 up to almost 700. It's true, it's approximately always 550, 600 expansion rate from aspiration type. Look, it's a typical construction. It's a foam inlet solution. There is air. There is a foam solution spray. There is a foam screen, and at the end we are having the foam. Oh, so there is some problem there. Here is a blower type. Here is a blower type. Blower type, its difference is because it's having a fan. Blower fan. So it means that always there is a much higher pressure of air used. So that's why the blower type of generator can work on much lower pressure. This generator Jetix 15X Ansul can work from 2.8 bar only. At 3.4 it's having perfect parameters. So that's why using a fan, it's always much better for you, because the amount of foam per one generator is much higher. So you don't need to make so many generators and so many holes for outside air. Okay, here you are having the compensation of inside air and outside air. Is a part which we spoke on the previous slides. Certificates. Please do always remember just to check its certificates. Do not look only data sheets. Look if anyone is claiming for you expansion rate of 800. Ask him for the test result. Not what is in data sheets. Ask him for test result. Believe me, that really often we see that in data sheets they are claiming 811, and then in their test result, like in CNBOP, it's 655. So please do check it always. Are they telling you true, or maybe they are just claiming something what they are not having? Okie dokie, let's play this movie. As you see here, this is our vents. These are the vents. And now in the movie, we will prove you. You can see every meter here. We will prove you. It was one from our investments that we will have a foam at 12 meters within only 2 minutes. 12 meters with only 2 minutes. Because many people don't believe that's possible. Have a foam on 12 meters with just only 10 minutes. Look this movie. Action should start it within a seconds. Okay, so you see. System started. Really important thing is when we are making a calculation that always in the high expansion system we need to have pressure reducing valve, because if you are calculating the expansion rate at let's say 5 bars, it should be always 5 bars on the generator. Within a high expansion forms we call it we got drums like a children. If you are just looking too high pressure, there will be no bubbles. If it's too low, there will be no bubbles. So you need to do proper pressure to have a bubbles. Same it's within a high expansion generator. So if you will put on a high expansion generator 9 bars, you will never have a foam expansion higher than 100, because it's been hitting the screen too fast. It should be, as we can see, just with 1 minute it was 6 meters, 1.1 is 7 meters, and look, you see how fast it's growing? This is not a test from FM or UL, as we are having also tests. It's a test, true test from one of our investments. That's why we are always happy if at the end we will check, is our system working at site, at job site, always. We are not happy if client is telling us, okay, it will be a lot of cost of this test. No, we are always saying that please do first test, check it that everything will be done properly. We are just only human being. We can make mistakes always. Look what is happening. This system at the end is also because of these outlet vents in the roof. It's also protecting the roof from above from a hitting. Okay, they shut down the valve. Here you can see how generator is working from the top. Look what is happening. Of course, it's happening because they didn't close in a good moment installation. But see, that's working. I can share with you numbers of installations which we did. And always you will see that as we claim 2 minutes or 3 minutes, depends, we just have them. Okay, here are the pictures from the other investments and a movie. Oh, anyone can ask, can I move in the foam, high expansion foam? This guy is proving you that yes, you can. Yes, you can. I heard this before. You see, it's easy. Just protect the nose and mouth, and you can just easily walk inside the high expansion foam. Okay, examples of assembly. It's really important. Look how big is this generator. This guy in blue is so small. This generator JetX15 is really big. That's why you don't need crazy amount of the generators. You can have it for 2,000 meters. You can have it 20 generators. Test here. Every one of you should know about your Raben company. With Raben, we worked over 4 years to make a standard for them for protection high dangerous liquids, flammable liquids, and together we developed the special bunkers for the worst materials. And here is a movie from tests which we did just 2 weeks ago. It was really high big area, because it was over 8,000 square meters, where we are having the submergence height of 12 meters. So it was crazy area. We just delivered over 81. It was 81 JetX generators. A complete system was done according to FM. So all system we just gave a declaration of conformity. That's exactly everything according to FM standard. It's really good for Raben Group, as they can have multiple insurers, and always when it's a FM system, they can always be sure that they will have the policy with the nice percent, not with the high percent. And what is really good, this system, our system, it's now standard system in 13 countries in Europe where is a Raben. So it means that we constantly every year build for our next several years. We will build for them new bunkers together, as Raben says that they would like to have only our system. And if we can just prove it, how it's good working.
Raben Group constantly invests in the latest systems to guarantee the safety of goods entrusted by its customers. Another investment of the group in safety is a special chamber dedicated to the storage of flammable liquids equipped with a high-expansion foam extinguishing system. This is one of the first such solutions among logistics operators in Europe and the first one in Poland. The system is automatically activated by an integrated smoke detection system. The chamber is filled with foam within 3 minutes, effectively extinguishing the fire in its initial phase. Thanks to a special foam forming agent, nearly 1 cubic meter of foam is obtained from 1 liter of water. The most effective and most modern fire protection solutions are investments in safety, which is the highest priority for us.
What else I can say it? What else I can say it if this movie is an official website of the Raben Group and you just saw. They are really happy because of having our system. And what we see on the market, because of Raben now it's spending money on innovations, and because now they can use much higher height where they can store the dangerous liquids, their offer for their client per square meter is much better, because they can, instead of 7.6 meters, now they can go up even up to 12 meters of the height. So that's why they are now on their market having really good offer instead of their competitors. So what now are making their competitors? Their competitors are coming to my company. So we can work together on the other projects, and it's a really good solution. It's a really good solution and proved by FM, UL, and CNBOP approval. So you can be 100% sure that's working well if such a company as Raben Group is happy because of having them. First, let's show this movie. Look, the vents are hydraulically opening. Here you can see the inlet vents and the outlet vents. Outlet vents we need to have because we will create too high pressure inside the building. So it means that walls can even collapse, or maybe it will be a problem with adding much more foam. As we can see, we just calculate here on a 5.2 bar, and it's exactly on the manometer. We can see that's a 5.2 bar. It's really fresh movie from 2 weeks ago. Let's see the next generator. Here is an outlet vent. Please remember that one generator here is putting inside something like a 400 cubic meters of air. So that's why the outlet vents are so important. Look, this crazy amount of foam going from each generator. And now they are stopping installation. As they reach the level which they would like to test. It was 5 meters. And we did 5 meters within 40 seconds. Okie dokie. Oh, it's from other places. You can see the pictures how this high expansion foam is going out. Here's here it's a wall type of mounting, because it can be roof and also wall. Here is a hangar. Here is a insider system, hot foam system. Here is a typical mounting of HG25 generators. Thank you for your attention.
Thank you very much, Kamil. Thank you, first of all, for your good mood and this enthusiastic way of presenting very, very, very effective efficiency foam. The thing I've totally forgot from my university in fire safety engineering studies. But now, in this way, we will never forget that. That's it. That's for sure. Okay, now going back to products, yeah, we can, Kęstutis, we can speak a lot about best practice designs and different approaches, but we always come back to the products and fire safety systems. So in this case, I'd like to present Mercor Corporation and one of the biggest companies, producer in Europe, which combines active and passive fire safety in its production. First of all, which really admires me the most is the smoke exhaust fans, smoke curtains, fire dampers, and we also come back to all the fire stopping systems, because Dunamenti, the Hungarian company, is now bought by Mercor, and wow. Well, we admire this this player because it's getting more and more interested. Now, I'd like to give a word to Eugeniusz Bugayev, who will talk about the scope of production of Mercor Corporation, and I will be really glad to hear all this presentation. Eugeniusz, the floor is yours.
Hello, dear forum participants. My name is Evgeny Bugayev. I represent Mercor Company, and today I'd like to talk about products that our company manufactures in order to provide passive fire defense in all sorts of buildings. The Mercor Company was founded in 1987, and for more than 30 years has been shipping its products to countries all over the world. At the moment, the company has 8 plants that are located in 5 countries, 4 in Poland, and 1 in Russia, Ukraine, Hungary, and Spain. Our company products are shipped to more than 50 countries all over the world on all the continents. Our proposal features 4 key directions. It's gravitational smoke removal, daylight ventilation system, mechanical fire ventilation systems, building structure protections, and fire partitions. So, natural smoke exhausting products serve to provide safe evacuation of staff from buildings on fire, and also allow the fire brigade, upon finding the source of the fire, to extinguish the fire successfully. Natural smoke exhausting also helps to save property within the building on fire, because other than the smoke removal and combustion gases, there's also a decrease in temperature which prevents the spread of the fire. So the key products of our first direction are natural smoke exhaust systems. It's vents, skylights, and hatches. ProLight, hatches, MCR Pro Roof, continuous roof lights, and lowered vents for smoke removal and ventilation, vents and skylights with high energy efficiency, MCR Ultratherm, smoke exhaust windows, smoke curtains, and also control systems for the whole natural exhaust system. So, in a bit more detail on the smoke removal hatch. That's the most common product we have within this group. The key task of these hatches is to remove the smoke during the fire and also the combustion gases from facilities where fire is found. The hatches can be operated with electrical or pneumatic systems, and also a possibility of being opened manually from the roof. The smoke exhaust hatches can be broadly modified in order to satisfy all the demands of the customer as well as the design team. Other than that, the hatches can be effectively used at the time of the fire, as well as for daily use. First of all, for natural ventilation and daylight. Due to the fact that the hatches are installed in the roof and not in the wall, they let in more light, and the level of lighting is much higher than would be provided by similar size windows installed in the walls. As the next product I'd like to speak about are continuous roof lights, once again with smoke removal hatches. This product is the most effective solution for natural daylight lighting in buildings, in large area buildings. Especially it has to do with production facilities where it takes daylight for comfort of the staff. The comfort level in the building that's equipped with continuous roof lights is much higher than with regular daylight. Other than that, the use of continuous roof lights significantly decreases the cost for lighting. Continuous roof lights can be up to 6 meters wide, and the length can go up, and the length is not limited just due to its modular structure. The length can only be limited by the actual length of the building. In our proposal, we have, other than arch hatches, we also have roof lights of triangular type, pyramidal domes, and that's why these products can be installed not only in at warehouse and production facilities, but also in buildings with higher static requirements, and can be more viable alternative for similar installations made of glass. And all of these products are equipped with smoke removal hatches and ventilation hatches that serve the same function of smoke removal and combustion gases, and decreasing the temperature within the building. The next product I'd like to present is louvered vents. They serve all of the above-mentioned functions, such as smoke removal, heat removal, ventilation, and also lighting. The key advantage of these hatches is universality, due to the fact that such hatches can be installed on the roof, just a regular hatch, as well as in the walls. The next product I'd like to speak of is smoke removal hatches, energy efficient hatches, and that's our response to the higher demands for energy efficiency. Regarding PVH profiles used, such hatch does not have cold bridges, and at the moment is the most energy efficient product in the natural smoke exhaust market with a heat loss ratio of 0.8. And we also have smoke exhaust windows. Smoke exhaust windows that are manufactured with the use of unique aluminum profile that was specially developed to the individual demands of the market. And due to the fact that the windows are equipped with three-layer glass, we get energy efficiency ratio of 0.8, just like the previous hatches. Another very important element of natural smoke exhaust systems is smoke curtains. Smoke curtains are installed on the edge, on the border of the special zones and prevent the spread of smoke throughout the building. Smoke curtains hold back smoke in the smoke area and thus limiting the damage to the property in other facilities. We have two kinds of smoke curtains, automatic smoke curtains, and as well as and also static curtains. So for production facilities and logistics, we use static smoke curtains, and for malls where such fire equipment should not be seen and should only go down in case of fire, we use automatic smoke curtains. An important element of the whole natural smoke exhaust system is the actual control system. In order for the system to work properly, it takes a specially designed system, and as a company, we have the fullest line of various systems, starting with pneumatic systems all the way to electric low voltage systems, 24-volt system, as well as 48-volt systems. And for some markets, we also use manual opening with the use of gas amortization. The second direction of our product line has to do with forced fire ventilation elements. Fire ventilation is based on exhaust fans and removes smoke, and thus providing safe evacuation. And dampers are part of the ventilation system and prevent the spread of fire and smoke to the other parts of the building. So the key elements of forced fire ventilation are cutoff fire valves, MCR zip, fire dampers, square type and round type, Fit Pro, also fire dampers and smoke dampers of curtain type, two versions. Also roof fans, MCR Passat, Monson and Bora. From then on, we have similar execution, intake fans, control systems, ventilation control systems, control fans and dampers specially developed individually for each product, because each building because each building has its own number of fans and smoke dampers. So every time it's designed as per individual needs. Also have a excessive pressure system for smoke exhaust on stairwells, and also jet ventilation systems for garage ventilation. Now I'd like to go into a bit more detail on valves, anti-smoke and anti-fire smokes. Anti-fire valves are part of ventilation system, and they automatically close during the fire, and thus prevent the fire spreading around the building, and also not letting them into the ventilation system. They're installed in channels, fire ventilation channels, or in smoke shafts, and depending on the fire scenario, they can either open or close. As a part of our product line, we have a lot of regular, so to say, fire dampers, square and round of various types, and we also have shutter dampers and smoke valves. In this case, such valves are used where regular valves cannot be installed, and all of the valves are fireproof anywhere from 60 to 120 minutes, and all of the valves are certified with the European standards. From then on, I'd like to move on to fire fans, centrifugal fans, Passat, MCR Passat, with anywhere from F200 to F600, and capacity of up to 520 cubic meters an hour, with a pressure of 1900 pascals. Actual fan monsoon, MCR monsoon, that are meant for smoke exhaust and hot air removal, and it can also be used as regular fans. It is fireproof anywhere from F200 to F400, with capacity of anywhere from 120 meters, 120 cubic meters an hour, with a pressure of 2000 pascals. The jet fan MCR bore is one of the energy efficient solutions for forced fire ventilation in underground garage, underground parking lots, in enclosed buildings. Our third direction is building structure protections. What I'd like to say is that in case of fire and high temperatures within the building, building structures like walls, floor slabs vary their carrying capacity, which can cause collapse of some fragments of the building and a complete collapse of the building. Such products protect the bearing constructions and help these elements to remain intact when it comes to the buildings that are protected by our products. And now we're going to move on to the actual products. The first product we'd like to speak of is a spray system, MCR TechWool F, based on mineral wool, and it's based for protection of steel, concrete, columns, as well as floor slabs and beams. The next system is MCR Isoverm 825. It's used for protection of steel objects from fire. It is used in oil industry, and it provides protection from fire anywhere from 32 to 140 minutes. Also, we have a proposal on intumescent coating systems, MCR Polylac for steel constructions protection. It's fireproof anywhere from 15 to 120 minutes. We also have sealing systems for walls and ceilings, combined installation penetration ceilings, cable protection, and plastic and steel pipes. Okay, fireproof sealing tapes for construction gaps. Also, board systems. I will speak of them in a bit more detail later. Also, next, a spray acoustical system coating, and also fire safety bars. MCR seal board is one of our new and most hopeful products. It's magnesium boards, MCR tech board, and also MCR seal board. Made from calcium silicate, and such boards are broadly used both in fire safety as well as in other areas. First of all, it's fire protection for steel and concrete beams with a maximum parameter of 66 hours of fire. It's also used for floor slabs and walls that are not load-bearing. They're also broadly used in smoke channels with a fireproof factor of 120 minutes. Beyond everything mentioned, our boards are also used in production of fire valves and doors, and they are used in modular homes and are broadly used in other areas. The fourth direction and the final direction is fire-resistant partitions. Fire-resistant partitions is something that is made by our daughter company, GFM Doors. Their product line includes various kinds of doors. First of all, fire safety doors, wooden doors, fireproof doors, technical doors, steel doors, and doors and general use doors. To summarize, I'd like to draw your attention to a broad range of services we offer, starting with the actual design, product design, design of fire scenarios. We help to design things. We create sets of all the necessary parameters, and we also do production, and we do sales, installation, assembly, and also service. So all of those, all of the interested companies are invited to collaborate with us. And on this slide you can see my contact information. So feel free to get in touch, and thank you.
Thank you very much, Eugeniusz. I'm really glad to hear all this scope and see how big and various all this product range is. And really saying the Mercor brand is quite known in Baltic region, so I'm really glad you're expanding and showing us more and with more quality. Thank you very much once again. Kęstutis, let's go further. Firefighting, not exactly firefighting, but fire extinguishing. It's common way of fighting
the most important
fire, and
system.
most important. We have prefabricated firefighting pipes.
Yeah.
I do know that in your activities you are dealing with fire extinguishing.
Yeah.
Is it a common thing for you?
Yes, it's common thing for us, and we try to some objects, some buildings to implement that view, but there is some tricky points to implement that. It's the fastest way to install, because you have prefabricated system, you assemble, it's very fast and easy, so it's very nice thing. But when you comes in the construction site, where is there a lot of ventilation ducts and pipings, other pipings related with the building. So there is some crosses where it's not so easy to solve in the B model or other things. So it's a little bit complicated.
Okay, so there's a challenge for also technical supervisor on a construction site.
Course,
so to make that all those engineering communications don't collide, I do understand. But BIM models do help us.
Yes, it helps and a lot, but not 100%.
Okay,
So it's always you have meet some crosses and changes, because the design also is a live thing, so it's changing all the time during the construction.
Okay, nice. All right, so we have our partners from Spain, and Jose de Antonio will represent us engineered fire piping, and we shall hear a very, very interesting topic. Jose, the stage is yours.
Good morning to everybody, or good afternoon, and I don't know. Let me introduce myself. My name is Jose de Antonio. I am the technical manager of Engineered Fire Piping. We are a company that works on the prefab of the pipes. We started working on this, but now we have moved to all the aspects of the fire protection system, and we can supply not only the pipes, but also couplings and everything that is related with the sprinkler system. The topic of today is to talk about some alternative sprinkler design system that we have in the last times to protect one of the most challenging areas that we need to protect with sprinkler, that is the warehouse. So I will explain you the new options we have to protect the high-bay storage with less sprinklers, less in-rack sprinkler, and less water. This is some option that the FM is offering us with a new concept that is the virtual floor. Let me do a small introduction to the situation of the problem. You know that logistic is very challenging for the sprinklers for a lot of reasons. Maybe because you know that the warehouse is a nice place, plenty of goods, very valuable goods sometimes, ready to burn. Okay, we have a lot of plastic. We have a very, very, very high building, and the fire load is growing and growing. So this is a very challenging, as I said. But on the other hand, we don't want to have nothing that can affect the actuation. We need to have a very fast moving, very fast. We don't want to spend a lot of time to having ready the order we need to send. So we need to have the less of obstacles to our job in the daily works in the warehouse. So nobody wants to have in-rack sprinklers, because it's something that can affect the warehouse function. So for a lot of years, sprinkler manufacturer, insurance companies, and everybody has been working in a solution to protect the warehouse only with in-rack sprinklers. We don't want to have, with the ceiling sprinkler. That was the reason we have a lot of different sprinklers to protect the buildings only from the ceiling. So the typical, we call the ESF water sprinkler that everybody knows, but this kind of sprinkler has a limit. That in this moment is in a building having 16 meters high. We cannot protect over 16 meters with only a sprinkler on the ceiling. Even with the bigger sprinkler we have in this moment, that is a sprinkler having a K factor of if we're talking metric, is 480. That means that you can deliver 480 liters by minute working at 1 bar. But even with this kind of sprinkler, we cannot go up this limit, 16 meters, and we have a lot of limitation. We have only for single and double row racks, and we have only for different, not for all the commodities. So this 16 meters limit need to be we need to be find a way to protect the warehouse over this limit with the less amount of in-rack sprinkler. For this solution, FM created years ago the concept of virtual floor. You can see on the slide, you see that we have a level of sprinkler on the middle of the rack, and this virtual floor allows this concept allow us to split a building having maybe 30 meters height in 3 buildings having only 10 meters height, with one level of in-rack sprinkler every 10 to 12 meters. This kind of concept allow us to protect the buildings, these virtual buildings in an individual way. That means that we can protect one part of the virtual building without discharge water on the other part of the building, even if one is on the top of the other one. We create a barrier. This concept of virtual floor is an option that can offer to the warehouse owners maybe the best solution in this moment to protect with the same level of protection the warehouse, and by using less sprinkler and always, and something that is important, less water. We will show now the 2 different ways we have to create this virtual flow, or to move through this virtual flow concept. The first one we have is to use the option with no barriers. We have 2 options, with barrier and with no barriers. The first option we have is to protect with no horizontal barrier. That means that we don't need to use a physical barrier under the level of a sprinkler. For this kind of protection, we have 2 possibilities. This concept was created by FM, but now we can have also on NFPA on FPA the same concept, so we can select in one way, or NFPA or FM, depending of the requirement of the insurance company or the end user of the country we are working in. If we move to the option we have here, we have to choose the option in selecting 3 different aspects of the problem. In what way? We have the type of storage. We have single row racks. That means that if we have single row racks, we have some kind of distribution, and depending of the size of the rack, we can distribute the sprinkler in a different pattern. We have 3 options. We have, depending on the width of the rack, we have up to 0.9 meters. You see that we have the sprinklers in the middle of the transverse flue, with the maximum distance between the sprinkler at 1.4 meters. If the row rack is up to 1.8 meter width, and then we have the sprinkler not on the middle, but we have the sprinkler on the face of the rack. We have one face, other face, we have in one phase we have a configuration that we can call every other. That means that we have sprinkler, no sprinkler, sprinkler, no sprinkler, and on the other phase we have the same sprinkler, no sprinkler. So we have a different situation, but at the end we have one sprinkler in every transverse fluid space. And if the rack is close to the wall, we can install one of the lines close to the wall if the distance between the wall to the rack is less than 0.3 meters. This is related with the distribution of the sprinkler on the horizontal plane, because for the vertical distance between the in-rack sprinkler, we have two options, depending on the commodity classification. If we have a product that can be classified between class 1 to 4 or cartoned plastic, we can have up to 12 meters between in-rack levels. If we have expanded plastic, we can have 9 meters between rack levels. That means that if we have 24 meters high storage, we need to use only one level of in-rack sprinkler, because the first part of the rack is protected with the in-rack sprinkler, and the second part of the rack is protected by the ceiling sprinkler. Now we can move to the next slide. And here we have the option when we have double row rack instead of one single row rack. In that case, regarding the distance, the vertical distance between the in-rack levels is the same distance because it is related with the goods we are protecting, the classification of the commodities. But regarding the distribution of each level, we have two options. If the rack has up to 2.7 meter width, we have 3 lines of sprinkler on each level. We have 2 phase lines and 1 line in the longitudinal fluid space. On the phase, we have the configuration that we call every other. That means it's 1 sprinkler, no sprinkler, 1 sprinkler, no sprinkler. And on the middle, we have the configuration, we have every. That means that we have sprinkler, sprinkler, sprinkler. This is for the rack having up to 2.7 meters width. If we have from 2.7 to 3.7, we have every configuration in the same, in all the lines. We have in the phase sprinkler and in the longitudinal fluid space sprinkler, the configuration that is every, that is 1 sprinkler in every transverse fluid space. And the next configuration is for multiple row racks. In that case, regarding the distance between in-rack sprinkler is the same. There is no difference. It is related with the classification of the goods. That means that we have or 12 or 9 meters, depending how challenging the goods are for the sprinklers. And for the situation of the sprinkler on every level, we have for the phase sprinkler that we call phase sprinkler, the sprinkler that are facing the aisles, we have the configuration we call every other. That means it's yes, no, in both sides, and in the middle we have the configuration that we call every, that is all the confluence of the transverse fluid space with the longitudinal fluid space has a sprinkler. So it's yes, 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 yes. With these 3 configurations, we can protect no matter how high the building is. Now we need to repeat the level of sprinkler, the distribution of sprinkler every 12 or every 9 meters. So this allows us to protect no matter how high the building is. No, there is no limit on the building height. But what about the requirement? How we can, we have the sprinkler, we have installed the sprinkler, but we need to know exactly how we can design the system from the point of view of the water requirement. And in that case, we can show both options with FM and NFPA because there are some, not too big, but there are some small difference between the requirement of FM and NFPA. Always FM used to be more have a requirement more strength than NFPA, but in that case it's different. NFPA is more demanding than FM. In that table, we can see how to design the sprinkler for the in-rack situation. Here we have the different options regarding the configuration of the rack. You remember that we have single row racks up to 0.9 meters, single row rack up to 1.8 meters, and single row rack over 1.8. We have also two options for double row racks up to 2.7 and from 2.7 to 3.6 and multiple row racks. And on the columns we have on the right, we have the number of sprinklers that we need to include on the design. And that is related with the classification of the goods, the type of commodity we have. On the first column, we have for the class 1 through class 4 and plastic carton, that means that plastic that are inside the carton box. We have 4 sprinkler, 5 sprinkler. We start in 4, and the most challenging will be 6, that for multiple row racks. If we are protecting uncartoned plastic, then we have for the single row rack is the same, but for double and multiple row rack, we have 5 plus 5 sprinklers. That means not 6, but 5 plus 5 sprinklers. Are the most demanding 10 sprinklers in the system. In one rack, 5, and the other rack, another 5. This is about the number of sprinklers, but now we need to know how many liters each sprinkler has to flow. And this is included on the following table. Here we have the option we can choose regarding the good we are protecting. And also it is related with the vertical distance between the in-rack sprinkler. You remember that we can use 9 of 12. 9 is an option for all the class we are protecting. 12 is only an option for class 1 to 4 and cartoned plastic. And on the column we have on the right, we have the K factor of the sprinkler. You see that we have the smaller sprinkler we have is the K14 or K200, and the biggest one is the K22, that means K2020. And on the right, we have how many liters each sprinkler has to flow. So on the first table, we have the number of sprinklers. Here we have how many liters each sprinkler has to flow. With that, we can decide how to protect how to design, how to size the pipe and the water supply for the in-rack sprinklers. For the sprinklers on the ceiling, you remember that we split the building in several virtual buildings. For the ceiling, we use the same table that we use for a building having the storage height and building height that is equal to the distance from the top in-rack sprinkler, from the top in-rack sprinkler to the ceiling. So we go to the standard table on the 8/9 datasheet of FM, and we can decide how to protect the top of the rack with the ceiling sprinkler. This is with NFPA. Now we will see the option that FM can offer to us. And you see that here the same is more or less the same. The only difference is that in the place that NFPA or FM ask on 6 plus 6 or 5 plus 5 sprinkler, NFPA ask for 6 plus 6. That means that NFPA is requiring two more sprinkler flowing in the case of multiple row racks and exposed plastic. So the only difference is that NFPA asks for 12 sprinkler and FM is asking for 10 sprinkler. The number of sprinkler is not too big, but the flow rate could be very high, because if we are flowing, if its sprinkler is flowing close to 500 liters by minute, to a sprinkler is around 1,000 liters by minute more. So it's important, the difference between NFPA and FM. And the flow rate is the same. I mean, there is no difference. It's the same, and the type of sprinkler is the same. This kind of sprinkler that we are using in racks are the ESFR. It's the ESFR that we have been using for years for protecting warehouse, just installed on the ceiling. There is no any special sprinkler. It's the same sprinkler, but with different application. Now we are using it not only on the ceiling, but in rack. The idea is to create a barrier, a virtual barrier with the water the sprinkler are discharging, that allow us to, as I said at the beginning, to split the building and to avoid the fire to move from the one level to the other level. With this option, we don't need to add the water from the in-rack sprinkler to the ceiling sprinkler, and at the end of the day, we need less water. This is the first option we have to protect the warehouse with this special configuration in rack. But we have also another option. This option includes the installation of some horizontal barriers. This horizontal barrier that you can see on the picture is nothing special. It's just plywood that is approximately has a 10 millimeter thickness. That means it's a special wood. Wood is nothing. We don't need to have any special barrier. It's just wood. And the option here, the most important here, is that the sprinkler is not a standard sprinkler. The use of this kind of protection can only be done with the installation of very, very special sprinkler that maybe not all the people know. Is a K25 or K260 extended coverage pendant sprinkler that is used in racks. We will see the option. We have also the same option with NFPA and FM, but if in the first option we have seen, it was FM who designed or who create the first design. In this case, it has been NFPA who have created the first design, and then FM has followed the requirement of NFPA, but in a way a little bit more complicated. So in this case today we are going to see only the more in depth the NFPA option, and we can talk a little bit only about the FM, because it's very complicated and it is very important to read carefully the data sheets, because there are a lot of exceptions. There are a lot of notes that you have to take into account, and it's very dangerous not to read it carefully, because you can create a big problem and maybe the system can fail. So we are going to focus on NFPA but with some reference to FM. Here you see a picture of how the rack is look like when we are using this configuration. You see the rack is empty, and you can see the barrier is horizontal barrier that is installed at the same level that we are going to install the sprinkler. The sprinkler are always installed under the barrier. And on the right, you have two columns. The column of the right is the NFPA configuration, and the column of the left is the FM configuration. If you have a look carefully, you can see that on the right we have two options of distance between in-rack sprinkler. We have 9 meters or we have 6 meters. 9 meters is for class 1 to 4 and cartoned plastic, and 6 meters is for exposed plastic. On the left, we have only 9 meters because NFPA allows the use or the protection of all these commodities, but FM only allows the protection of class 1 to 4 and cartoned plastic with this kind of protection, with this configuration barrier are this standard coverage sprinkler. On the next slide, we can see the requirement of NFPA for the different options we have regarding single, double, or multiple row racks. This is the option for single row racks, and you see that we can have, if you remember, and with the other sprinkler, we have one sprinkler on every single transverse flue space. Here we have the configuration that we used to call every other. That means that we have one sprinkler, yes, one space, yes, another no, yes, no, yes, no. And we have two options. We can install the sprinkler on the middle of the transverse flue space, and we can install the sprinkler if the rack is close to the wall, we can install the sprinkler close to the wall. And on the right, on the top, we have the distance, the vertical distance between the in-rack sprinklers. As you remember, we have two. We have 1.1 meters for the class 1 to 4 and cartoned plastic, and 6.1 meters for the exposed plastic, no matter if they are expanded or unexpanded. And this is the NFPA. There is no any reference here to FM because in any case, in no case FM allows the protection of exposed plastic with this configuration. And on the left, you have the distance. The A is the distance that is depending. The commodity can be a 9 or 6, and C is the distance we have between the last barrier, the last level of a sprinkler, and the ceiling. C is the distance we will use to select the ceiling protection, and A is the distance we use to select the in-rack protection. For the option of double row racks, we have only this distribution. You see, we have in the longitudinal transverse, on the longitudinal flue space, we have the every other configuration. So it's one sprinkler, is no, yes, no, yes, no, yes, is every other. For the distance between the levels is the same, 9.1 or 6.1, and regarding the vertical distance is the same, is A for the in-rack, C for the ceiling sprinklers. And the distance between the sprinkler is up to 3.1 meters maximum. And the last configuration we have is here. Well, you can see the blue line is the barrier. That means that we have the blue line. The blue line means that we have a plywood, and under the plywood we have the sprinklers. If we have 3 levels, we have 3 barriers. If we have 2 levels, we have 2 barriers. In that case, we help the sprinkler to create this virtual floor with some physical barrier. Here is not only the water that the sprinkler are discharging, who creates the barrier. It's a combination of water sprinkler discharge and barrier, a physical barrier. We will see that here we need less water and you can see less sprinkler, because don't forget that this is an extended coverage sprinkler. In this kind of installation, okay, being a extended coverage is not a big, has not a big difference that the different we have when we have the sprinkler on the ceiling. Don't forget that for with a extended coverage sprinkler, we can protect in a warehouse on the ceiling up to more or less 18 meters, and with a standard sprinkler we can protect 9. That means that the distance, the area that we can protect on the ceiling with the extended coverage sprinkler is double that the one we have with the standard coverage sprinkler. But in the racks, the distance is just from 2.4 to 3.1. There is not a big difference, okay? But in a case, there is a difference. And the last option we have is the multiple row racks. Here we have a distribution for multiple row racks, and we have sprinklers. The sprinklers are distributed in a very similar way, but we have two lines that are close to the aisles. That means that we have we call phase sprinkler, and we have line on the middle that are installed on the longitudinal fluid space that is on the middle of the rack. The distance, the maximum width we can protect with this kind of configuration of sprinkler, the maximum rack width we can protect is 4.7 meters. That means that if we have a rack bigger than this, we cannot use this option to protect the rack. It is important that there is a limit. This limit is 4.7 meters width. Okay. And again, we see the blue line that is the barrier. Again, is a wood barrier. It's not nothing special. It's a 10 millimeter thickness thick plywood, and the distance is also 9.1 and 6.1. Is again and again depending of the products we are protecting. For the less challenging, 9.1. For the more challenging, 6.1. And once we have the distribution of the sprinkler, we need to know how to design the system. How many sprinklers need to be flowing, how many water every sprinkler has to discharge, and on the ceiling, how many sprinklers we need to use. For the in-rack sprinkler, we have only one option. There is not some more option with the same way we have in the other distribution. We have K14, we have K22. Here we have only one sprinkler, and is a standard coverage pendant K25 control mode density area. It's not an ESFR, it's not a control, it's not a specific application sprinkler, it's a density area sprinkler, but has K factor of 25, imperial K factor, or 360 in the metric system, and the design is based on the flow rate of 520 liters minutes by one sprinkler for a sprinkler, and the number of a sprinkler is 4 in the case of single and double row racks, and 8 in the case of multiple row rack. So we have 4 sprinklers flowing 520 liters by minute in single and double row racks, and 8 sprinklers flowing the same quantity, the same flow with the same flow rate in the case of multiple row racks. And regarding the ceiling, is the same that we have seen in the option in the before. Is this distance we have from the highest level of in-rack sprinkler to the ceiling. This is for us is a warehouse. We don't need to take into consideration the remaining areas of the of the rack, and we protect this last level with the protection we will require for a building having, say, the same height we have from the sprinkler to the ceiling. So we need to use the standard process. We follow the standard process that we have in only one floor building. And I will show you the requirement of NFPA that are in the following table, and you can see that are a little bit different because the sprinkler is the same. We have also single row rack, double row rack, multiple row rack, but we have only products from class 1 to 4 and cartoned plastic, nothing expanded, nothing uncartoned. And you see that we have the different rack depth. And we have another thing that we need to take into account, the aisles width. Depending of the aisles width, we have a different requirement. If the width of the aisle is 1.2, we need 6 sprinklers. It is up to 1.2, we need only 3. If you are familiar with the European standard, with the EN 12845, you remember that the number of sprinklers, when we are designing in rack sprinkler, the number of sprinklers is always the same in every rack, but the number of rack is based on the aisles width. Is more or less the same. The reason is for a small width of the aisles, the possibility of the fire to move from one rack to the other rack is bigger. So the closer the rack are, the bigger the possibilities for the fire to move to one rack to the other rack. If it's very close, we need to have the possibility to open a sprinkler in 2 racks. If the width of the aisle is bigger, the fire cannot move, or is not that as easy for the fire to move from one rack to the other rack, and in that case, we only need water in one rack. It's more or less the same idea that we have on the European standard. Okay, and well, we can see that we have also for double row racks, we have depending of the aisles or 8 or 4, and for multiple row rack, we have no matter how width, no matter the width of the aisle, we have always 8. That means that you see that there is a little bit different between NFPA and FM. Following the requirement of FM are a little bit more complicated, and there are a lot, as I said there are a lot of small letters that you have to read carefully between the one article, another article. In the middle, there are a lot of small letters that can change a lot the requirement, and it's important because the small letter also needs to be followed. And after that, we can move to a resume of the summary of this concept of virtual floor, and then I will show you some examples of how to protect at least 3 different warehouses by following the 3 the option we have seen till now. Here you see that this is the summary of this idea of the virtual floor. We have an unlimited storage height. We can have, the problem is not the sprinkler, the problem is the building. If we can reach 40 meters, we can protect 40 meters. We have to only repeat every 10, 12, 9 meters in rack sprinkler. It's just a matter of number of racks, but there is no limit on the storage height. We have no, with this is the, what we have seen, this is the virtual floor concept. And with this concept, as we have already said, we don't need to balance the sprinklers or the ceiling of the sprinkler in racks. Are 2 different systems and it will never work together. So we have to size our water supply based on the most demanding system, or in rack or ceiling. Sometimes it could be rack, sometimes it could be ceiling, but never both together, or ceiling or in rack. So the systems are independent. We don't need to balance. That is not is something that when we are using the standard concept of in rack sprinkler, you know that we need to balance ceiling and in rack. They are always working together, and we need to run some hydraulic calculation with both systems working together. Here, we don't need to do that. The ceiling sprinkler and the in rack sprinkler are independent. This also allows us to have a big amount of goods over the last or over the top level of in-rack sprinkler. With the standard concept, we have some limitation. The limitation is the distance between the one in-rack sprinkler and the other one. Or sometimes in some standard is that you can have only one load over the last in-rack sprinkler. For example, in the European standard, you are limited to one load. In other standard, you are limited to 3 meters, 4 meters. Here, we have no limits. We can increase the storage height over the last in-rack sprinkler up to the limit. We can do it. The limit is how big the building we can protect only from the ceiling. If we have or the distance between the in-rack sprinkler, if we have 14 meters, we cannot have 14 meters. We have only 4, or we have only 3, because we need to add another level of in-rack sprinkler. But there is no limit. The limit is bigger, or there is limit, but the limit is bigger than the limit we have in the standard system. And with all these requirements, we need less water, because we don't need to add the requirement of the system on the ceiling and the requirement of the system in rack. So the water we need is less. So the pump we need is smaller, and the water tank we need is also smaller. Now we will see 3 examples of 3 warehouses. On the first 2 one are I use it to show you how we can manage to protect the same building with 2 options based on if we have an existing pump system with a limited capacity, and we can manage to adapt the requirement of our warehouse to the pump we have by using one option or other option. We will see 2 different options for the same warehouse on the first 2 examples, and we will see on the last example, we will see another option by using barriers. Okay, the first example is a warehouse that is a 35 meters high buildings. We have a 33.5 storage meters. We have double row racks with 2.5 meters deep. We are protecting cartonate and expanded plastic. And we want to use the FM Global 8.9 dataset. It's on the chapter 2.3.6.6. And with no barriers, that means that we will use the first option, no barriers. And when we have cartonate and expanded plastic, we can use one level of a sprinkler every 12 meters, because we have cartonate and expanded plastic. If we were using cartonate expanded plastic, we will need to move to 9.1, but we are on the limit, so we can use 12. So we will have one level at 12 meters, another level at 24 meters, and the remaining area or remain part of the warehouse will be protected by the sprinkler that are in the ceiling at 35 meters high. So we have split our warehouse in 3 warehouses, one having 12 meters high, another having another 12 meters high, and the last one having 11 meters high. So we will protect with our warehouse following this requirement, and the first step we need to do is to decide how many liters and how many sprinklers are included on the design of the in-rack sprinkler. The horizontal distribution of the sprinkler, taking into account that the rack has up to 2.7 meters. We have the sprinkler distribution you can see on the drawing, on the picture, is on the face sprinkler. We have the every other option, and on the longitudinal fluid place we have the every. So we have yes, no, and yes, yes, yes. This is the horizontal distribution of the sprinkler. Regarding the requirement of the system, from one side we need to decide how many sprinklers we will have on the in-rack sprinkler design. How many sprinklers has to be open or will probably be open, and the flow rate of each one, and on the other side we have to design the ceiling sprinkler. For the number of in-rack sprinklers we need, you remember that we have a table for this configuration with double row racks up to 2.7 deep. We have 6 sprinklers, and when we have 12 meters distance into the rack levels, we need to use the K22 sprinkler flowing 455 liters by minute. So at the end, we have, for the racks, we need 6 times 455 liters by minute, means 2,730 liters by minute. And for the ceiling sprinkler, we need to go to the general table protection for this kind of product is table 8 on the 8.9 dataset on FM. And if we use the the K22 to have the same sprinkler on ceiling and in racks, we need, according to this table, 9 sprinklers working at 3.5 bars. It is very important to take into account that this has been a big change. Always, we will have always 12 sprinklers when we are using ESFR, or this green area in the tables that are the old ESFR, because you know that ESFR is a concept that is not now used by FM. But they have changed. This is the late edition of the late revision of the FM dataset. It was done in July of this year, and they have changed. There is not 12 sprinkler, but 9 sprinkler. So for the ceiling, we need for this virtual building we have that has 12 meters. We need to use the requirement for 12 meters. We have 9 sprinkler, K20 320 working at 3.5 bars. That means that we need 5,387 liters by minute. On the old concept, we need to add the rack flow and the ceiling flow. In that case, we don't need to do it. So we have to design our water supply for 5,387 liters by minute. And also our water tank have to be sized for this requirement. So this is something that has changed with the other with the old concept of in-rack sprinkler. But we can have another option to protect the same building. The same building is 35 meters, is 33.5 storage height, is the same row rack. We have the same commodity, but we have a problem. Our pump is not able to supply the 5,000 liters we need. We have only supplied 4,000. Then we can try to have a different option. Why not to use another option? The other option could be the use of split the building not in 12 but in 9 meters. In that case, we have another level of a sprinkler more. We don't have 2, we have 3. We can see here that we have at 9, 18, and 27 and 27 meters, and the ceiling at 35. Okay, with this different distribution of sprinkler, if we move to the requirement, we will see that we need less water, because in that case, we have 6 sprinklers. It's the same number of sprinklers, but for 9 meters and this commodity, we can use K14, we can use K200, is the same, flowing 250 liters. So we need, for the in-rack sprinkler, we need 6 times 250, that means 1,500 liters by minute. But the main change is on the ceiling, because now we are protecting a building that has not 12, but has 10 meters height. So we can, it has 9 meters. So we can use less water for the ceiling. We can use the same number of sprinkler, but flowing less water, because the sprinkler will work at 1.4 bar instead of 3.5 bar. So we have 3,400 liters. So by increasing one level of in-rack sprinkler, we can decrease the water we need. So if our problem is that our pump cannot cover the requirement, we can change it and we can have less water, and we don't need to change the pump. That is, sometimes could be important, sometimes not, depends. But the most important is that we have options. We can play with the option, and we can adapt, not always, but we can adapt the requirement we have at the water supply we have. Sometimes, not always, but well, if we have this option, it could be important for us. And the last example we have is a little bit different, because here we are going to use the barrier option. Okay, in that case, we have the same building, we have the same storage, we have the same racks, but we have cartoned expanded plastic. That means that having expanded plastic, we cannot use FM, and we are going to use NFPA, and we can go to up to 9 meters distance using. We can use both NFPA or FM, but we are going to use NFPA because the problem is when we have uncartoned plastic, and here we have cartoned. That means that it's the same with NFPA or FM. Sorry. But we have to use NFPA 13, it's section 2583 with horizontal barrier. In that case, we cannot move up to 12. 9 is the limit for this configuration. So we have, in that case, also 3 levels of sprinklers. But in that case, we have a sprinkler and barrier at 9 meters, 18 meters, and 27 meters. So we have barrier of a sprinkler, 3 levels. And we will see on the distribution, on the horizontal distribution of each level, you can see that we have only a sprinkler on the longitudinal flue space, and with every other configuration is yes, no, okay? And the requirement, according to NFPA, are for the in-rack sprinkler, you remember that we have 4 sprinklers. Each sprinkler has to flow for 520 liters by minute. So the 4 sprinkler is 2,080 liters by minute. And for the ceiling sprinkler, we have to move to the standard table on NFPA. In that case, is table 2361, that is the protection with ESFR in rack sprinklers. And we have 7.6 meter for storage 8 in a building having 9.1 meter. That is the distance we have between the last level of in-rack sprinkler to the ceiling is 9 meters. And with this configuration is a building for us having 9 meters with a 7.6 meter storage 8. We go to the table and we have that we can use 12 sprinkler K240 working and 2.4 bars. That means that we need 4,460 liters by minute. And here also we don't need to add the in-rack sprinkler requirement to the ceiling sprinkler. So we will size our system for 4,460 liters by minute. This is the last example. Okay, I just want to thank you for your passion and sorry for this big lot of information because there are a lot of information together. But I think that with this information, you can go to the standard NFPA or FM. But it's important to take into account, especially with FM, that they change a lot. They used to change every 6 months, and sometimes they change something that can affect the design we are going to do. So every time we work with FM, it's important to check on the website if there is something new that can affect us. With NFPA, it's a little bit different because they change every 2 years, but also it's very important to take into account that we are using the late revision of the standard. And in any case, I will say thanks again. And if you have some comments, here you have my mail address. And if I can help you in something, don't hesitate to send me a mail. And again, thank you very much and bye.
Thank you, Jose. Really worth listening to your presentation. It's really a bit even opened my eyes in the design of prefabricated parts. Really interesting. Now, a very long and tough day, Kęstutis, isn't it?
Yes, yes.
But yeah, really worth. First day is always tough. But how do you find it? How do you like it?
It's very interesting, I think, to hear and see all our presenters. Very interesting themes, and it's very nice day, I think. Very tough, but very nice.
Yeah.
So, and I think that in totally the Fire Forum in Baltic countries, I think we had a lack of these events like this, yes, and the sharing of the information and sharing experience to meet each other and to now know the actual information. It comes evaluation of products, evaluation of the norms and regulations, and some events like ladders and so on. It's very interesting for me,
Yeah,
especially personally.
It's really
yes.
worth listening to.
And I have to say that thanks for all presenters.
They did a good job.
It's
a good job, really.
Yeah, big job done. So
what I share with you is also a good word, sharing. Sometimes we know a lot, but we have a lack of sharing. So I hope this platform, the Baltic Fire Forum, will eventually become a sharing, a knowledge sharing platform. So guys, I'm really thankful for your patience. Thank you, everybody. And see you tomorrow at 10 o'clock. We shall continue the second day of the second edition of Baltic Fire Forum. Thank you and see you.
Thank you.